Tradoon.
Let's protect our fossils, because if they're removed, America loses them forever.
No, glue is cheap.
Tradoon. Tradoon. Tradoon.
Glue is cheap.
Tradoon.
briefest of moments. Every last man at Shawshank was a pink little dinosaur, too.
Well, hello, everybody, and welcome back to Paleontologizing. Moonpie is here to say hello as well. And a very, very happy early Easter to all of you. We're going to be discussing the EASTER Bilby today. How does that sound, Moonpie? You better not be actually consuming that
Tribune.
plastic. No, she isn't. Good. It's going to be a very mammal-heavy stream today. If the mammal on the desk and the mammal in the chair here aren't any indication of that. They are an indication of that, I suppose. Moonpie, you doing some grazing on those plastic plants? Anyway, welcome to Paleontologizing, everybody. My name is Danny Anduza, and I'm a dinosaur paleontologist. There are lots of different kinds of paleontologists who study different kinds of fossil organisms. Yeah, fossil mammals, like Moonpie here, and like myself. Neither of us are fossils, but we're mammals. There are paleontologists who study all kinds of different invertebrates, crustaceans and insects, and myriapods, trilobites. There are paleontologists who study fossil plants, or fossil fungi, fossil plankton, or dinosaurs too. Dinosaur paleontologists, we're but a small minority within the paleontological community. But we get a lot of attention. Dinosaurs are what I study and what I dig up and what I publish on in the scientific literature. Usually what I talk about 5 days a week here on Twitch, but today is a special day. We're going to be celebrating marsupial mammals today in honor of the EASTER Bilby, which is altogether too appropriate with Easter coming up on Sunday. Anyway, it's good to have you here, everybody, and we're going to have a fun stream. Here on Paleontologizing, the whole purpose of these broadcasts is to give people an inside peek into how fossil science works. Do that by answering your questions, going over some of the latest discoveries and publications in fossil science, talking about what paleontologists do, and even bringing you along for the ride when I'm out in the field digging up dinosaurs. In less than 2 months now, I'm going to be out on the road and then in the field in Wyoming digging up dinosaurs live on camera. Really looking forward to that. So we'll be doing that at the end of May. But yeah. And Guts, we're mostly just Guts 2001. It's good to have you here, by the way. We're mostly just talking about marsupials today. It's not going to be a lot of Easter stuff. It's just an excuse to talk about this wonderful little mammal. The bilby. Yeah. We'll be talking about why these critters are so important.
Dinosaurs became extinct because they no longer knew how to love each other. Is that correct?
No, that's not correct. What?
Exactly.
Huh?
And I certainly wouldn't want our species to end the same way.
Niffler, thank you for the 8
Another
months.
month of learning fantastic things in a great community has flown by. Also nice of Moonpie to pop in to celebrate my sub-anniversary.
You hear that, Moonpie? Yeah. Thank you, Niffler, for the 8 months of support. Really appreciate it. Thank you for helping make these streams possible with your support. It means a lot. And Moonpie, you're really going at that plant, huh? Moonpie herself is not a marsupial. She's a placental mammal. We'll be talking about the difference today. There she is on our cat cam. What you got there, Moonpie? What you got there? Yeah, you are shedding like crazy. Your fur is flying. And she really likes my plastic plant right there. She can't get enough. See, this is why I have plastic plants. Is because if they were real, they would be gone already. Come on, Moonpie. Yeah, that's why we keep the real plants outside. You can't get to them. Yeah. Who's that walking by over there? Is that Lordy? Yeah. Oh. And Lanita, thank you, by the way, for the raid earlier. I must have missed that. It must have been during the cold open video. But Lenina, I hope you had a wonderful stream. It was wonderful to be able to pop in. Glad you were on again. And if anybody watching right now is not yet following Lenina, she is on her way to getting affiliate so that she can start maybe making a little bit of money and also have emotes and stuff like that. I told Lenina I was going to make a Plockman's mustard emote for her. I'll see if I can do that on Sunday. So go give Lenina a follow. She was playing something called Lunar, Silver Star Story, complete. I'm not familiar with that game, but it kind of reminded me of when I saw Ios play one of the Final Fantasy games. One of the old ones like that. It reminded me of that. So anyway, go follow Lenina and catch some of her streams, and let's get her that affiliate status, because she deserves it. She's done so much for this community, as everyone here knows. One of our tireless moderators, and
I can see that my 50,000 a year has been well spent.
And Ironbark, 19 months now at tier 3. Thank you, Ironbark. That is exquisite, and I really appreciate it, Ironbark. Thank you. Yeah. Excellent. Good stuff. But yeah. And Ios would like Lunar? She's probably played it already, Gary and Kellis. I should ask her. If she shows up on stream, maybe you could ask her. But yeah. Anyway, Lenina, thank you for the raid. I appreciate it. And I presume you had the day off today? In some countries around the world, today is a day off. Might be a bank holiday here in the States. I'm not sure. But there's a holiday called Easter.
Really spectacular, spared no expense.
And Lordy, thank you for that gift
Gifted
sub.
a
I
tier
appreciate
1 sub
it.
to Hedgehog O'Brien.
I really do. Yeah. It reminds me of a moment here, actually. Easter is one of those holidays that's been around for a long, long time. It's kind of derived from a solstice or equinox celebration around springtime.
What? Oh, what noble...
And Easter, too. And Geolox, I'm glad you're doing fine. It's good to see you. Anyway, in much the same way that holidays kind of grow and change and we suit them to our own purposes and everything, people in the land of Australia have done the same thing with Easter and the Easter Bunny, transmuting it into the Easter Bilby. Allow me to show you. Take a look at this right here.
Easter is in full swing, and chocolate is on the minds of many. But will it be a bunny or a bilby that makes its way into your home? Brightly red.
And it's not as terrifying as Easter Bunnies usually are Retro Roadshow. Holy cow. I personally think the Easter Bilby's a lot cuter. And, oh, the museum thing all about? I can't really talk about that yet. But, suffice to say, there's exciting things happening. Hopefully I'll be able to make some announcements soon. But yeah. And then, let's see. Guts 2001 said, did dromaeosaurs use their wings to control their jumps, kind of flapping them? Guts, there is a paper you should take a look at here. Yeah, maybe you've heard of the raptor prey restraint hypothesis? This is something that my old crew chief, Denver Fowler, him and colleagues came up with this. This idea that dromaeosaurs would have used their wings to stay on top of their prey as they're holding it down and kind of eating it alive. Like you see here.
Really spectacular. Spared no expense.
Let's see.
Oscar JRS gifted a tier 1 sub to Addy_the_great.
And thank you, Oscar Juniors, for that gift sub there. I really appreciate it. Yeah, here is the paper. Right here. The predatory ecology of Deinonychus and the origin of flapping in birds. You can click the download PDF button right here. Let me just give you the link to the paper itself. But, there you go, Guts. Enjoy. This is a really, really cool paper. I will talk about this in the future, but it's kind of off topic for today, so we're going to focus on our Australian marsupials and marsupials around the world. We'll see where this goes. And Bruce, too, says, I love what you're doing here. This gives me good old Reading Rainbow and Bob Ross vibes. I appreciate that, Bruce, too. I really do. Thank you. That's high praise. Welcome to the channel. I hope you feel comfortable here. Let me know if you happen to have any questions at all about, well, about today's topic, first and foremost. The Easter bilby. Billies are such cool animals. Marsupials in general are such cool animals. Or if you've got questions about dinosaurs, because that's what I actually study, what I publish on, what I dig up. Dinosaurs are my area of expertise. That's what I actually work on. Or if you've got questions about natural history in general, about extinction and evolution, the origins of biodiversity, all that stuff, do not hesitate with your questions. It's the beauty of a live broadcast like this, is I can answer them for you live. It's that interactivity that makes Twitch special, and I'm trying to use it to get people jazzed about science. So I'm glad you're here. Chrissy Carson Art. Oh boy, I gotta be careful not to get too off topic here. These wonderful questions. Chrissy Carson Art says, what are your favorite natural history museums? I have a few. Let's see. In Dickinson, North Dakota, is the Badlands Dinosaur Museum, which is run by my old crew chief, Denver Fowler, the same guy who did the raptor prey restraint hypothesis, the dromaeosaurs thing. Shoot, some of my handiwork is actually visible in this photo. I did some work for the museum back in 2017. And, yeah, it's a pretty cool place. This is one of my favorite museums in the world. If you're ever in North Dakota, make sure you visit.
Hi, my name is Dr. Denver Fowler, and I'm the curator of paleontology here at Badlands Dinosaur Museum, Dickinson Museum Center. So what I love about the Badlands Dinosaur Museum is the opportunity that we have to do something different.
Yep.
We're planning our new exhibits.
This is a specimen I collected with Liz. This is our big hadrosaur forelimb right there. Probably Brachylophosaurus, although it could be Gryposaurus. But yeah, Liz and I spent so long digging this thing out of the ground. It was quite the undertaking. And some of the footage from that is actually in my my welcome video. If we get a big raid, then I'll play that and you'll see it. But when I'm like down in a hole using a hammer and a chisel, that's working on this specimen, trying to get this big slab of rock cracked off from the rest of the rock there so that we could haul it out, bring it back to the lab and get it prepped like
planning our new exhibits in a way that's different from what you'll have seen before at other museums. We want a diverse of exhibits. We want to have unique specimens that you can't see anywhere else, and tell stories about basically being a dinosaur detective. How do we find out?
And this is fairly new.
How these
Chrissy
animals
Carson.
lived? What's the process of?
So this museum right here, the Badlands Dinosaur Museum, wasn't open until 2016, I believe. Denver Fowler got hired on there. I So Denver and I go way back. I used to do field work with him. He was kind of my mentor in the field back when I lived in Montana. And he graduated with his PhD under Jack Horner, and then he needed to get a job. And there was a job opening at this museum in North Dakota. This museum had opened back in the early 1990s, during like the Jurassic Park craze of the 90s. And it was like a little private museum, and then it went out of business, I think in the early 2000s. Then somehow a deal came about where the city of Dickinson, the city that this museum is in, it's really a town. It's not a city by California standards, but the town purchased the museum and now runs it as a municipal museum on the municipal budget. And they needed a paleontologist. Denver Fowler applied for the job. He didn't have a car at the time, so I drove him all the way across Montana and North Dakota for 2 different job interviews on 2 different occasions. And that was a ton of fun. And, of course, he got the job. He was the best guy for the job. And now he is trying to turn this little institution into one of the next great dinosaur museums. And he's succeeding. Here, take a look.
It was a big, unique mission that required the National Guard and its helicopters. 2 creatures, roughly 70 million years old, airlifted near Farmington today. News 13's Madeline Schmidt and our Sky News 13 crew were there and show you.
Nope, sorry, this is the wrong one. It's a different helicopter. They had a Chinook, an even bigger helicopter for that one. Darn, where is it? Maybe they don't have video of it, but I can show you a news article. Yeah. There we go. Badlands Dinosaur Museum airlifts Tyrannosaur from Montana to Dickinson. And there should be some photos here, right? There's no photos of the helicopter? What? Got images. There we go. Yeah. Dinosaur, nearly complete Tyrannosaur, flies out of Valley County. Oh boy. Or subscription. Anyway. Good stuff. Good stuff. And Lythronax 888, it sounds like you're in the right place. How are you doing? Welcome to Paleontologizing. I know some of the people who dug up and described Lythronax. I was in North Dakota a few years ago in the Hell Creek Formation. Would have loved to visit that museum. Next time you're in North Dakota, don't miss it. It's pretty awesome. Yeah. And is it near the national park? It is near the national park, Christy Carsonard. Yeah. Yeah. Anyway, it's good to have you here, Lythronax. Shoot, I remember when that genus was first published. We had
If you're feeling a bit cheated, try blaming the dinosaurs.
And Sculpin, thank you for the 100 bits. Appreciate that. Hello to you too. Lythronax, I remember when that paper first came out. Lythronax argestes. Yeah. Speaking of Denver Fowler, we were having a meeting of the Dead Lizard Society at Montana State University. Our, organization where we would get together and discuss new scientific papers. And, this one came out. The name Lythronax means the King of Gore. It's an early-ish Tyrannosaur from Utah. And the big part of the paper is that it lived in the southern part of the Laramidian subcontinent. There we go. Yeah. So North America used to be split into 2 and at some points 3 subcontinents. When the Western Interior Seaway flooded the western interior. We're often pretty straightforward with our names. Dinosaurs were cut off from each other, and they seem to have evolved into unique forms in Appalachia and Laramidia. That's going to be a theme today as we're talking about marsupials also. But anyway, we're all sitting around discussing this paper, and then I remember this joke that Denver made about the name Lythronax. He said it sounded like something out of a pharmaceutical commercial, you know? And Laramidia almost sounded like some sort of a disease, so it was like, you know, has Laramidia got you down? Ask your doctor if Lythronax is right for you. But yeah. Anyway, good stuff. It's good to have you here, Lythronax. Welcome to Paleontologizing. And Gary and Kelly says if only those old dinos had water floats. I mean, they would have been pretty good at swimming. But we're still kind of unsure how different the dinosaurs are in Laramidia versus Appalachia. Because almost all the dinosaurs that we know of from this time, from North America, are from Laramidia. Dinosaur fossils from Appalachia are very rare. And so maybe they were very different over here, or maybe they weren't. But, yeah. This is a pretty long distance to swim. But dinosaurs like Tyrannosaurus, for instance, who evolved later on, would have been pretty excellent swimmers. Here. And, gotta be thirsty. Gem CR, there you go. Cheers. Thank you for the hydrate. There you go, Guts. I love that this series opened with a shot of Tyrannosaurus swimming.
Tyrannosaurus Rex, surely the most terrifying hunter that ever existed. These huge teeth are evidence enough of its efficiency as a hunter, and studies of the skull have also shown that it had an acute sense of smell.
Yep.
But what evidence is there that it ever went for a swim?
Yeah. I think they were actually pretty decent swimmers.
Tyrannosaurus Rex swimming with his young may seem surprising, but like all of the dinosaur behavior in prehistoric planet, this is backed up by some remarkable science.
I did not see that stoicide. Interesting. Gotta stay still and take a bath. There you go, Gary and Kelly.
Were massive.
Well, Melissa had excellent sight too, so don't let it see you.
Scales at around 10 tons.
Paleo cat, yeah.
Perhaps an obvious candidate to be a swimmer.
I'll look at that paper in a second.
T-Rex is part of a group of dinosaurs called the theropods. That's the predatory dinosaurs. And one of the key features of this group of dinosaurs is they had large, very muscular, bird-like hind limbs, which were mostly built for walking and running.
But would have been good for swimming
such
too.
legs would also be effective in swimming.
Yeah, well, here, we don't have too much time today, so we're going to fast forward through this. We actually have direct fossil evidence of them swimming. We've got what we call swim traces, where like in lacustrine sediments, so like lake bottom sediments, there are these weird scratch marks that they match up with, you know, when ostriches or emus go swimming, and they leave the same traces like that. Yeah.
Sediment on the bottom of lakes, rivers, and the seabed as they swam.
Yep. And lightweight skeleton, especially the axial skeleton, very, very lightweight, full of air, would have helped with buoyancy, just like it does in modern birds. Yeah. Other creatures like elephants are surprisingly good at swimming, despite being more dense than theropod dinosaurs. And ostriches.
And perhaps surprisingly, these animals are really good swimmers. There are places where these birds make sea crossings, sometimes of several miles, so they can reach offshore islands and find new sources of food.
Yep. Yeah, so T-Rex swimming makes a lot of sense. Anyway. And And what is this? New instances of ceratopsian teeth from Appalachia imply multi-phase late Cretaceous migrations. Very cool. Yeah, very cool. Pretty awesome. Yeah. Non-avian dinosaur remains from late Cretaceous of southern Appalachia are consistently rare. What did I tell you, chat? There it is. In the literature. Or at least in the conference abstract, right, Ken? Yeah. Ceratopsians are perhaps the rarest, with only 3 potential basal neoceratopsians and 1 ceratopsid being recorded to date. Here we describe 2 new teeth that we attribute to a ceratopsian from the late Santonian-aged Tumbigby, it's a fun name, Tumbigby sand member, and the Utah Formation of the Lowndes County, Mississippi. Maxillary teeth are different from those more common hadrosauriform. Neat. Yeah, the transgressions and regressions of the interior seaways allowed for pulses of ceratopsian migrations from Laramidia to Appalachia. If so, then derived ceratopsians would have been present in Appalachia up to 17 million years prior to previous literature suggestions. This makes a lot of sense. It's hard to keep big animals in one spot. They have a tendency to move. They tend to have wide ranges. They seek out new opportunities to find food. They can sometimes do things like even cross mountain ranges or, you know, shallow seaways or whatever. That's how we got mammoths out on the Channel Islands off the coast of California. They swam there several miles through seawater. Oh yeah. Yeah. And there you go, Pontius Pirate, yes. Few animals that cannot swim. That's true. Yeah. Yeah. That's neat stuff, Ken. That's neat stuff. And yet, Easter stream, Fedorasaur. And look who's here to celebrate with us. It's Sweetie Pie. Yeah, how are you doing, sweetie? We've had Moon Pie, and now here comes Sweetie Pie. Yeah. Sorry, I brushed your leg there, sweetie. She's like, don't touch my legs. Oh. Yeah, hello. And look, there's a treat yesterday that I got for Moon Pie. And she didn't want it, because Moon Pie doesn't like treats. I was demonstrating to the chat that she doesn't like treats. So yeah. Hey, we could get another cat trick today, Lenina. That would be awesome. And Sweetie decided to get up today. Yeah, she was asleep on the bed for I don't know how long. Oh, Sweetie Pie. Yeah. Yep, all we need is Mini Pie, and then we're 3 for 3. And you are fluffy, aren't you, Sweetie Pie? Yeah. Good stuff, Sweetie Pie. Jim Sear says, I love looking at cats on stream because I'm allergic. I'm actually mildly allergic to cats as well. But living with 3 cats, that has since gone away. Yeah, the more time I found myself spending with cats, the less allergic I was. I guess my immune system finally got with the program. Yeah. And there you go, Wanapata. How are you doing, Wanapata? Long time no see. How are things? It's good to have you here. Here's Sweetie Pie. Look at you. Look at the camera here. Yeah. You having a good day, Sweetie Pie? What do you think? We're going to be talking about bilbies today, Sweetie Pie. That's another kind of mammal. You're a mammal, I'm a mammal, but bilbies are marsupials, very different from placental mammals like you and me. Yeah. Good stuff. Good stuff. And it is an early stream today, Mayor Space. Yes, indeed. And that crikey is quite appropriate. Because we're going to be talking about a very, very cool Australian mammal today. The bilby. Here, take a look at this.
It's that time of year again, when crosses appear on buns, chocolate gets transformed into eggs, and a mysterious, often giant bunny leaves them for people to find. Nothing unusual about that. But here in Australia, real, regular-sized bunnies are actually quite a problem.
Yep.
Rabbits are an introduced species that like
They're
to
invasive.
eat crops and native plants. They reproduce really quickly and compete with native animals for food and habitat.
Yep. Contrast that with the
Some
bilby.
people reckon here in Australia we could be celebrating Easter with another cute, fluffy mammal in mind.
Yep, one with long ears. So this is essentially like it's like a marsupial rabbit. It is a marsupial, but it's convergent upon like the rabbit body plan. They kind of hop around. They've got these long ears. They burrow in the ground. They're Australia's answer to a rabbit. Not related to rabbits at all, but they are. They occupy the same kind of niche, you know? Pretty cool.
Bilby.
The bilby.
Bilbies are a native species which are believed to have lived in Australia for around 15 million years. They were once found across 70% of the country, and there were originally two species, the greater bilby and the lesser bilby. But the lesser bilby is thought to have become extinct in the early 1950s.
Yeah, we've got the lesser bilby here on my office wall today. This is the now extinct lesser bilby. And now we only have the greater bilby right here. But these are really, really cool critters. I love bilbies too, Dino Wolf. They are such neat animals.
Nowadays, bilbies are listed as vulnerable, with fewer than 10,000 of them left in the wild. And guess what? Rabbits are one of the reasons these little guys are struggling. Isn't that right, Cora?
An interesting one, Apata. Never heard of these. Had to Google the name in my language, and they are literally bag rabbits or ear baggies. I wonder if bag there is a reference to the pouch, because these are marsupials. They carry their young in a pouch. We'll be talking about maybe why and how that evolved in a little bit, if we have time to get to it. But, yeah, I wonder if that's where the bag part comes from. Yes, we call all the marsupials a bag something. That's neat, Wanapata. That is neat. It's intuitive. Yeah. Yeah.
Bilbies are vulnerable due to mainly introduced species, such as foxes and cats. And sometimes
And rabbits.
A competition with the rabbits and stuff as well.
Yep. Rabbits are taking their homes.
To help raise awareness of the troubles bilbies face, this chocolate company decided to try making a chocolate Easter bilby back in the 1990s after a ranger suggested it. And it took
Such a cool
off.
idea.
When we brought the bilby in, we didn't really know how popular it would be. And then after a few years, the bilby was outselling the rabbits, so we discontinued the rabbits and became bilby only.
Since then, more than 800,000
Yes.
chocolate Easter bilbies have rolled off the production line. And
we're going to be looking at some of those today, because I got a box in the mail from Rosand down in Straya. He sent me some chocolate bilbies, so we're going to take a look at those too.
part of the money made from selling them goes towards helping bilby populations get back on their feet.
The raising of the money from the chocolates, the bilby chocolates, helps us with our breeding programs, the conservation side of things. We don't want them to dwindle anymore because we have lost a lot of Australian wildlife due to the people introduced species. So it's quite important just to recognise it, especially around Easter, just to promote them as much as we can.
Yeah.
So, in the spirit of Easter, I thought I'd better do my bit for the bilby and enjoy two of my favourite things, chocolate and cute animals. But I better not get those two confused.
Isn't that cool, Kay? Yeah.
That's definitely the chocolate one.
They are really good, actually. Oh yeah, Cool stuff. And Golganak, thank you for the 100 bits there, Golganak. I really appreciate that.
BILBY cuteness fee. Boop.
And maybe it's because you put it in all caps that she read it BILBY. But, yeah. They are such neat animals. They are such neat animals. Why don't we talk for a minute about why Australia has marsupials and what marsupials actually are. Let's take a look at this quick video from Smithsonian Channel to go over some background. And Lenina, thank you for that gift sub. I appreciate it, Lenina. Here, before we get into the video, actually, let's look at our tree of life. And let's look at mammals here, and you can see just how early on the split is between the Metatherian and Eutherian mammals. Yeah. There we go. And I've kind of figured out how to get the scroll wheel to work, but this mouse is on its last legs. I've ordered a new one. It should be here tomorrow, I hope. But here's mammals. And then, so, you know, you and me and Sweetie Pie here, and probably most of your best friends and family, and your sworn enemies are probably mostly mammals. Mammals are creatures that feed their young with milk. They all evolved from a common ancestor about 190 million years ago, something like that. All of our modern mammals share a common ancestor back in the Jurassic period, beginning of the Jurassic, around the same time that like Dilophosaurus was walking around. The first true mammals had just evolved then. And during the Mesozoic era, mammals were around. Their ancestors were around for even longer than that, obviously. The first, like, stem mammals are from, early Permian, something like that. Maybe later. But anyway, branching off earliest, you've got the monotremes. These are mammals that still lay eggs. The platypus, and I think 5 different species of echidna are on here. Monotremes on this branch. And then you get the therian mammals. This includes the placental mammals, which is the vast majority of all mammal species today. But then you've got the subject of today's stream, the marsupials, who claim Australia as their stronghold nowadays during the Neogene period. Marsupials are what we're going to talk about now. Take a look at this.
This joey is a few months old, but marsupials give birth to extremely underdeveloped young.
Dino Wolf, thank you for that gift sub. I appreciate it.
They're usually born around the size of a lentil, or in larger animals like kangaroos, a jelly bean, and they
they're born
the
extremely
pouch where
small.
they continue to grow, unlike placental mammals, which are born fully developed.
Yep. So these are basically born like super premature. They're super preemie mammals. Because they do most of their development outside of the womb in the pouch. Here. Newborn marsupial. They basically just look like a tiny little flesh bean. Like that right there. Sometimes they're born after only like 2 weeks of development, like 2 weeks after mating are they born, and they just like in figure A right there, they just look like tiny little pink jelly beans. They are incredibly small and underdeveloped when they're born. Yeah, they basically look like this right here. I think some of them don't even have hind limbs yet when they're born. trying to find that one photo where it really does just look like a tiny fleshy bean. Yeah, it's an interesting way to be born. It's almost kind of halfway in between being an egg-laying mammal and being a mammal that gives birth to live young. These are live young in a strict sense. But... oh, there we go. Right there. It looks kind of gross, but, you know, it is what it is. A newborn kangaroo right here. Its eyes aren't developed yet. It barely has a nostril to breathe with. It has forelimbs. I don't think it actually has hind limbs yet. I don't think the hind limbs have actually sprung forth in a lot of species of kangaroo like this. Yeah. They give birth to de facto embryos. They really do, Goganek. Yeah. Yeah. Yeah, and you can see the rib cage right there. I'm sure the bones aren't even ossified yet. They're probably still just like proto bones. They haven't even like fully turned to bone yet. But yeah, yeah. And there you go, Mayor Space. Yeah, they do have, I think there's a different name for the placenta in marsupials, but it's like, it's not developed to the same extent that it is in placental mammals. And how do they just appear in there, says Guts? Well, they actually have to move from the birth canal. They have to crawl with their tiny little arms. They have to make this huge journey from the mother's birth canal up into the pouch. And that actually has huge ramifications for how these animals are able to evolve. You'll probably never get a marsupial whale or a marsupial snake or any marsupials that don't have limbs, because using those limbs to crawl from the birth canal to the pouch, you have to have limbs. So we'll never have marsupial snakes, you know? Yeah, it does look like the Eraserhead baby, weird adult. You're right. You're right. But yeah. Yeah. Oh, and Dino Wolf says, I was told that marsupials started in America. They very well may have. Yeah, the thing is, the fossil history, the fossil record of very early mammals is very sparse. There's a bunch of different mammal groups that everybody says originated in North America. Primates, and camels, and pigs, and marsupials, and like a bunch of other groups. Bats are thought to have originated in North America too. But the thing is, I think a large part of that might be sample bias, where we've just had the most fossils from North America. So the earliest representatives from each of these groups happen to have been found in North America just because everybody's looking in North America. It's kind of like that old parable about, yeah, about looking under the lampposts. So a guy loses his keys. Another guy walks up and he says, "Lost your keys?" He says, "Yeah. I lost them over there, but the light's better here." In North America, the light's just better. We've got a lot of different exposures. We're looking for fossils. There are a lot of paleontologists who live in North America. There's just a lot of infrastructure for our fieldwork here in North America that doesn't exist in other parts of the world necessarily. So, yes, marsupials may have originated in North America. The earliest ones that we have are from North America, but that might just be because the light is better here, and we haven't found them in other places yet. But yeah. And yes, indeed, Britt, yeah, I'm, well, Easter is this Sunday, right? So, yeah. But yeah. Oh yeah, and Kelladon Cave, kangaroos can be very muscular indeed. They're yoked. Anyway, it's good to have you here, Britt. Shoot. I just replied to your email a little while ago, Britt. It's been such a crazy busy couple of weeks for me. And I've got cats on the desk. I've got papers that I'm writing. I've got a museum meeting today at 3. That's why I had to start super early today. There's so many things going on. But Britt is working on a project with 3D sculpting, digitally sculpting some Bilby models that people can 3D print. And Britt, if you have any information about that, feel free to share it in the chat there. And we might be doing a crossover stream sometime soon as well, me and Britt. We'll see. Yeah, and Javanzir says, so absence of evidence is not evidence of absence. Not necessarily. And it is hard to prove a negative. Yes. Yes. So it looks like, at this point, marsupials may have first evolved in North America, but that might just be because the fossil record of mammals from North America is particularly good. It's the best in the world. So yeah. Anyhow, I hope that makes sense. Let's get back to our video on marsupials here.
Some pouches face backwards, like the wombats.
And there you go, Mayor Space. Yeah, bandicoots.
These burrowing
are related to
marsupials
bilbies.
spend much of their time digging,
They're
so a
from
backwards-facing
similar group of
pouch
marsupials.
ensures it doesn't fill up with earth. Kangaroo pouches are perhaps the best known to humans. Powerful sphincter-like muscles keep babies safe inside until it's old enough to become more independent.
Oh, adorable.
But the short period in the womb versus the relatively long time spent developing in the pouch is one of the defining characteristics of marsupials.
And that's cool, Britt.
Australia
Yeah,
has
thank
more
you.
of them than anywhere else in the world.
Yeah. But why does Australia have more marsupials than anywhere else in the world, especially if marsupials didn't originally evolve in Australia? What's going on with that? You know? Here's a lovely PBS Eons video. Another southern continent, another Gondwanan continent. We've got Gondwana right here. Excuse me, sweetie pie. Here, let me take this down and show you. Yeah, these are the southern Gondwanan continents here. South America, Africa, India, Antarctica, and Australia all used to be part of this massive supercontinent, which we call Gondwana. Gondwana was in the south, Laurasia in the north, and when they were stuck together, it was called Pangaea, which means all Earth. But then when Pangaea started to split, first you had kind of that north-south split, like this. And so those continents used to be stuck together like that. And these different colored bands are different geological formations that extend throughout the continents. This is one of the first clues these continents were actually stuck together at one point, is you've got these continuous bands of rock go like that. So if you match those up and look at the outlines of the continents, they fit together like puzzle pieces. So that was one of our first clues back in like the 1950s and 60s that, shoot, those continents used to be stuck together. Australia's right here, and South America over here. There are some paleomammalogists, I think, who say that mammals may have originated in that marsupial mammals may have originated in South America. And if they did, they would have had to cross through Antarctica to get to Australia. And I think that might be what this video is about here. Let's take a look.
Along the eastern edge of the Andes Mountains in central Bolivia, you'll find the remains of an ancient calamity. The Badlands here are formed by sandstones and mudstones dating back to around 64 million years, the remnants of a time when this area was a warm, damp forest filled with palms and ferns. And it was home to a group of survivors that made it through the mass extinction event that wiped out the non-avian dinosaurs. These survivors were the mammals known as metatherians, which included some of the very first marsupials. But these animals were about to face a catastrophe of their own. One day or week or season back in the very early Paleocene epoch, a river overflowed its banks and flooded the burrows where these mammals lived. Anything unlucky enough to get caught up in the water quickly drowned, preserving them, this event, and their ecosystem. Today, we think of Australia as the continent of the marsupials, the one place where they reign supreme in a world dominated by placental mammals like us. But this place in South America was their original stronghold. This site in Bolivia, called Teopampa, was home to a small burrowing metatherian about the size of a mouse, known as Pucadelphus. And it lived alongside another mammal, Cassia, an early true marsupial and close relative of most of the marsupials alive today. From these two species, we can trace two parallel stories about these strange and remarkable animals, one that ends in extinction and one that ends in survival. Throughout the Cenozoic era, which is the era that we're in now, marsupials and their metatherian relatives flourished all over South America, filling all kinds of ecological niches and radiating into forms that still thrive on other continents. So where did these survivors of the dinosaur extinction, the metatherians and marsupials, come from? And if they were so abundant, how did their reign end? Why did some persist into the present day while others just vanished over time? Even though we think of Australia as the home of the vast majority of the world's marsupials, the cradle for their diversification and the bridge between their origins and their modern home would be in South America.
Yep. Important stuff.
To understand where South America's marsupials came from, we have to go back millions of years and to another continent where we find their earliest ancestors. Today's marsupials are the last surviving group of metatherians. But the earliest known fossil evidence of metatherians dates back to the early Cretaceous, about 125 million years ago, to fossils found in China. But based on genetic evidence as well as fossils, it seems that this group first appeared way back in the Jurassic period, between 178 million and 168 million years ago. Around this time, a split occurred in the mammal family tree.
Yep, and that was that same split that we saw right here. We've got our Therian mammals. There's a split between the Eutherians, which are placental mammals, and the marsupials. So in science, in paleontology and evolutionary biology, there's a million zillion different ways to draw trees like this, and it doesn't matter how you draw them as long as they're conveying the same information. So this right here is giving us the, oh, sorry. That splits here. Between the monotremes and the Therian mammals. This right here is conveying the same information as this. There's different ways that you can draw these trees. It doesn't really matter how you draw it as long as the same information is being portrayed. I want to make that make sense to you. Coming up sometime soon, I think we'll do a whole stream on phylogenetics and how to draw family trees and stuff like that. I'll come up with some sort of excuse to do a whole stream about that. And I think there's a pretty good resource for it on the Understanding Evolution website. I was talking with some colleagues at the museum about that last week. So yeah. And yet, Clapstop, yeah, there could be some sample bias because we don't have a lot of stuff from Antarctica yet. Absolutely, yeah. So yeah.
With metatherians forming one branch and the other containing eutherians, which includes all placental mammals like us and our closest extinct relatives. These first...
So that is, if we zoom out here, you get, the monotremes over here, the Therian mammals, and the placental mammal. Or, excuse me. You have mammals, then you've got monotremes, marsupials, and placental mammals. There's a split that occurs right here, further down from the split between Therians and monotremes. And that's exactly what you're seeing here. You've got mammals here. You've got that split between the Therians and the monotremes. And then you've got the Metatheria and Eutheria, the marsupials and their now extinct relatives. Marsupials are the only metatherians left, but there used to be other kinds of metatherians as well. Marsupial-like mammals that are now completely extinct. And then, of course, you have the eutherians, the placental mammals, the ones that give birth to live young that don't have a pouch. Unlike the metatherians, most of which did and still do. Does that make sense?
Includes all placental mammals like us and our closest extinct relatives. These first
Yeah.
metatherians were probably similar to the marsupials we know today, giving live birth shortly after conception and nurturing their tiny young outside the body. But the important thing to know is that not all metatherians are marsupials.
Yep.
For example, of our friends from Teopampa, Cassia was a marsupial while Pucadelphus was not. And it's really hard to pinpoint what traits make a fossil a member of one group rather than the other.
Yeah, in fact, that became obvious to me when we were talking about this critter, when I was doing some reading about Thylacosmilus. This is once called a marsupial saber-toothed cat, because it's not a cat at all. It's a metatherian mammal that probably had a pouch, and they're crazy weird. Oh shoot, I won't be able to take that off the wall right now. But Thylacosmilus. This animal, it might look like a cat. It looks kind of like moon pie, actually. This one's it's very moon pie coated. It's because the face looks kind of flat. I don't know. But, yeah, this is not a cat. Your Honor, I'm not a cat.
Mr. Ponton, I believe you have a filter turned on in the video settings. You might want to take
we're
a look.
trying to. Can you hear me, Judge?
I can hear you. I think it's a filter.
It is, and I don't know how to remove it. I've got my assistant here. She's trying to, but I'm prepared to go forward with it. I'm here live. I'm not a cat.
He's not a cat, nor is this animal a cat. I'm here live. I'm not a cat. This is not a cat. Even though it looks like a cat, it is absolutely not a cat. Thylacosmilus was a marsupial relative. And they're reconstructed in different ways, some of which look a little goofy like this. But, yeah. It's crazy the amount of convergent evolution you can have. That cat body plan just works, and so different groups of mammals that are not cats have each independently evolved this kind of feline body form, even though they don't come from that cat ancestor, even though they're not actually related to cats. So yeah, it's like a possum hiding as a cat sculpin. Yes, yeah, really, really cool. These are such neat animals, and unlike the true saber-toothed cats, who had their saber fangs kind of protrude down below their chin, these guys evolved these big flanges on their chin that were kind of like sheaths for those big saber fangs. Really wild. They are such neat critters. And they are, I think they're no longer considered to be true marsupials anymore. Let's see what Wikipedia has to say. Yeah, but it was a Sprastodon, a group closely related to marsupials, and only superficially resembled other saber-toothed mammals due to convergent evolution. Yeah. So Sprastodonts are related to modern marsupials, but I don't think they're... Yeah, they were once considered to be true marsupials, but are now thought to be a separate side branch that split before the last common ancestor of all modern marsupials. Does that make sense? Yeah. So I hope that answers your question, Ken. I think we're still kind of figuring that out. But yeah. Wild critters. They're so neat. But yeah, not only are they not marsupials, but obviously
She's trying to, but I'm prepared to go forward with it. I'm here live. I'm not a cat.
Yeah, they're not cats. And they're not true marsupials. But they're way, way closer to marsupials than they are to cats or any other placental mammal. So, yeah.
Than the other. Paleontology.
Here, just to make this extra clear, they are so on this tree, if you were to put Thylacosmilus and its relatives, the Spracodonts, on here, they'd be a little side branch that comes off right here before you get to the marsupials. This tree only really shows living animals. It doesn't really show extinct groups, or it would be way more crowded than this. But yeah, the Spracodonts, including Thylacosmilus, would like branch off right here. So it's like they're on the line going to marsupials, but they're not marsupials yet. Does that make sense? Marsupials all share a common ancestor here about 87 million years ago during the late Cretaceous. Yeah. Let's continue.
Just have to use complex statistics
And wombat hole, yeah.
that analyze things like skulls.
Tasmanian devils are marsupials too. Yeah.
Now, by the late Cretaceous period, some of these early Metatherians had arrived from Asia in North America, where they diversified into lots of new species.
Yeah, so that's a frustrating thing too. We ought to do a whole convergent evolution stream at some point. In fact, I'm going to write this down right now. We're going to do, at some point, all right, just down. We're going to do a, what did I say earlier? What kind of stream were we going to do? Convergent evolution stream, and we'll talk about that. We'll talk about the crab myth and all that. And yeah. Oh, yeah, we're gonna do phylogenetics. We're gonna do clades and trees, phylogenetic trees stream. And we'll do that before the convergent evolution one, because we'll be building on some themes from that. That'll be good. That'll be good. Yeah. And Kennedy says, who gets to decide how and where the line is for a group? That's the thing, Kennedy, is that there isn't a line. It's a fork. So all of evolution, the way that we classify living things, and this is going to be kind of the basis for that stream. I'm just going to give you the super condensed Cliff Notes version of it right here. You've got splitting events that occur. So the difference between mammals and reptiles is that their ancestors split. One group went in one direction and the other group went in another direction. That's what makes mammals different from reptiles. Does that make sense? That's why marsupials are different from placental mammals. There's a split that occurred, and you've got them on two different branches. Their ancestors, they had one ancestral species that split into two species, and then those two species had species that split off of them, and they just go in completely separate directions. They diversify, they diverge in wildly different ways. And you see that right here. So marsupials are this branch that split off, and then you get placental mammals over here. So that's why they are different. Placental mammals did not evolve from marsupials, and marsupials didn't evolve from placentals either. They both evolved from a common ancestor here. That's why, you know, there's this whole thing about like, well, you know, humans are fish. It's because there wasn't like a split that occurred there. You always are your ancestry. So if we go back further here to the amniotes and the tetrapods, lungfishes and tetrapods, and lobe-finned fishes, including tetrapods, we are part of this clade Sarcopterygii. We as human beings. So are cats, so are spracodonts, so are marsupials, so are bilbies, part of Marsupialia. We are all a kind of lobe-finned fish. You don't draw a line at a particular point and say, oh yeah, well these animals aren't fish anymore. It's like, no, they evolved from a lobe-finned fish ancestor. They are lobe-finned fish. Does that make sense? Yeah. And very funny stoicide. But yeah. Oh, but a species is marsupial-like, but not a true marsupial. Yeah, Kennedy, so in that case, it would be... that they share a lot of traits that make them look like marsupials, and they're closely related to them, but they branched off earlier. So, in order to be a true marsupial, you have to evolve from that common ancestor of all the marsupials. This is clade thinking. It's like a clade is the ancestor and all of its descendants form a clade. So Thylacosmilus and the other spracodonts like that, they're not part of this clade. They branched off earlier, before the first marsupial, the first, like, the common ancestor of the true marsupials, before that evolved. So they split off earlier than this. So they're close to the marsupials. They're very close. But they evolved before the first marsupials did. Does that make sense? Yeah. So yeah. OG Tony says on Thanksgiving, many folks are technically eating fish. Oh yeah. Yeah. Not me though. Because yams and corn, potatoes, bread are not fish. But if you're eating a tetrapod animal, you are eating fish. A turkey is a dinosaur. Well, a turkey is a bird is a dinosaur. Dinosaurs are reptiles. Reptiles are a kind of fish. Which in turn are a kind of animal. Does that make sense? Yeah. But if you're eating, I don't know, lobster on Thanksgiving, like the original Puritan pilgrims did eat lobster on Thanksgiving, I think. On the first Thanksgiving, or whatever. Lobsters are not fish. I'll show you. Lobsters are related to insects. They're arthropods. So you get lungfishes and tetrapods here. Let's jump to lobster. They are arthropods, related to, you know, related to things like crabs and insects, spiders, and shrimps. Yeah. No, true lobsters and crayfishes are a kind of arthropod, so they are not fishes. Does that make sense? Yeah. And lobsters are aquatic bugs. Yes, indeed, Kelladon K. Yes, indeed. Unless you go with the definition of true bugs, which is not a film starring Arnold Schwarzenegger and Jamie Lee Curtis. True bugs are a group of terrestrial insects with sucking mouthparts. The true bugs. Heteroptera. Yeah. Anyway. But true bugs, that's not a very good name. It's confusing. So we would use the scientific name for the clade, Heteroptera. So you don't get it mixed up with that movie with Arnold and Jamie Lee Curtis. So yeah. Yeah. It's an animated satire featuring Bugs Bunny and Jamie Lee Curtis. Gotcha, Gimplag. So it's like Space Jam.
I think you should enjoy science as much as you can.
Or Who Framed Roger Rabbit.
Science alone. You have to share it.
Trader Tots, thank you for the 2 months of support. I appreciate that. Thank you for supporting science outreach here on Twitch. That means a lot, and I appreciate it. Thank you. Oh, Pepsi Junkie.
Because
thank you.
If they're removed, America loses them forever.
For that Prime sub, I really appreciate it. Thank you, Pepsi Junkie. And thank you, Blank by Simulacra, for the follow too. Welcome to Paleontologizing. It's good to have you here. Yeah. Cosmic Sequences, are new branches still happening? Oh, you bet. Absolutely, yes. The thing is, it's kind of hard to observe that over the course of a human lifetime, because it usually happens a bit more slowly than that. You know? We puny humans have a lifespan of what, 80 years if we're lucky? and new branches splitting off and evolving, it's difficult to observe that happening in real time because it takes a long time. Unless you're looking at things like bacteria that reproduce really quickly and evolve really quickly. Let me see if I can find a video about that to help explain this. Let's see. I don't know if I'm gonna be able to. Shoot. Yeah. Let's see. I'm trying to find a video that'll be quick so we can kind of stay on topic. But you know what? Let's take a look at this. From the fall of dinosaurs to the rise of humans, and that'll provide some. Well, no, it's gonna be too specific to mammals. Evolution. Describes biodiversity, maybe. What is evolution? Let's just take a look at this real quick from Stated Clearly. Yeah, this guy always does good work. And I really want to bring him on for an interview at some point. He's been so stupidly busy lately. But let's take a look at this. John Perry is his name.
Stated Clearly presents. What exactly is evolution? In biology, the theory of evolution doesn't tell us exactly how life began on Earth, but it helps us understand how life, once it came into existence, diversified into the many incredible forms we see now and in the fossil record.
Yeah, and this is incredibly important stuff. This is the very fundamental principle in all of biology. And yet, at least here in the United States, it usually doesn't get taught in schools. People go through biology classes in high school and stuff, and then they graduate high school, and they might know that, oh, the mitochondria is the powerhouse of the cell. Big whoop. Who cares? Like, it's I don't know, like, nothing against cellular biologists or anything, but the actual, like, underlying framework for all of this, why it's important, how it explains how we got here, and where life on Earth, how it's diversified over time, those are the real important concepts, and they're usually not taught in schools, and it's completely infuriating to paleontologists, to zoologists, to evolutionary biologists, Most people don't learn about this sort of thing in school, and it's because there's a small but very, very loud and powerful minority of religious fundamentalists who fight tooth and nail to keep this sort of thing out of the textbooks. I'll show you a brief little clip here. Yeah. Here.
Just as Darwin proposed. The reporters.
Oh, so this is from a documentary about a trial where creationists were trying to teach creationism in public school classrooms in Dover, Pennsylvania. There's a big court case about it, and there were some scientists who testified on the stand, including Kevin Padian here. And here, let's see what he has to say.
Bridge the gaps between species, resulting in a picture of gradual evolution, just as Darwin proposed.
Yep.
The reporters in the courtroom were just amazed that we knew all this stuff. And how come they hadn't learned about this stuff before? And the reason is, it's not in textbooks because the creationists fight so hard to keep it out. That's been a big influence.
Yep. The fundamental principle in all of biology is something that most students don't learn, unless maybe they go to college and take a biology course there. Then maybe they learn about this, but the vast majority of people don't have any clue about it because the creationists fight really hard to keep this sort of thing out of textbooks.
The infant, the adult.
Smorphosaurus.
Ontogeny.
Thank you for the
This
23
is a
months.
late lol. The alert never went off last stream I attended XD.
Well, I appreciate you very much, Smorphosaurus. Thank you so much for the 23 months of support, and how are things going with you? Can we get a shout out for Smorphosaurus? When's the next time that you're streaming, by the way? You've got some great emotes, and I think people might want to take a look at some of those. Would you care to put some emotes into the chat for us? Some lovely dinosaur emotes that Smorphosaurus has got. Get a hold of them if you can afford it and support Smorph there. Yeah. Anyway, what is evolution? How's it work? This is basic stuff. You know, but most people don't end up learning it in school, which is infuriating.
Diversified into the many incredible forms we see now and in the fossil record. It also helps us make sense of the way in which modern creatures continue to adapt and change today.
Yeah.
In biology,
and Kennedy says, having been taught evolution in school and having my kids also haven't been taught it as well. I thought, oh, your kids have been taught it as well. Might be a typo there. I had no idea large swaths of the U.S. didn't learn this. It's the majority of Americans never learn this, Kennedy. It's like 60 or 70% of Americans never really learn this in school. Maybe higher. Yeah.
Evolution can be defined as any change in the heritable traits. Those are physical traits like fur color in mice, spots on the wings of butterflies, or instinctive behaviors like the way that dogs greet their friends with a sniff, within a population across generations. This definition
Oh, wow, Smorph. Well, hopefully you'll be back up soon.
So let's see how it works.
Yeah.
All healthy living things, from single-celled amoebas to flowers to dolphins, are capable of reproduction. We have children.
And Salamander says, even knowing what I do know about evolution, it happens at such a scale that I have struggled to grasp. Wonder if it's because I didn't learn it in those malleable brain years. That might be part of it. Actually, that probably is a big part of it. But also, you know, they're big concepts. And evolution is like a high order idea. You have to kind of understand a lot of the fundamental stuff before you can really grasp how things work up here. So like I don't know. It is kind of a failure of education on a large scale too. But I don't know. You don't necessarily have to learn it in school though. Well, no, you should learn it in school. What am I saying? I didn't learn it in school. This wasn't taught to me in school. I learned all of this on my own. Reading books when I was a kid, and watching documentaries, and later on interacting with paleontologists once I was in high school. I was volunteering at a museum and got to hang out with paleontologists all summer long for like 4 years. But most people don't have the opportunity for that, you know? Or the drive for that, certainly. That's why this sort of thing needs to be taught in schools, because if you don't understand this, you really don't understand biology, and you really kind of don't understand the world around you. Things might still seem mysterious and mystical in ways that shouldn't. It's important to have a sense of wonder and mystery about the world, but have it be about the things that are actually wondrous and mysterious, you know? Yeah. There is a line from a character in 30 Rock that always reminds me of this. I need to find that clip. And I'm not going to find it, but... Yeah. Yeah, Kenneth from 30 Rock. He had this line at one point, and he's like, I just think there's some things that maybe science can never explain. Like where do we go after we die? And, how does bread become toast? And the thing is, we do know a lot about some of these things. Some of these things aren't mysteries anymore, Evolution is one of those things. There are a lot of the details that we're figuring out, and that is incredibly exciting, and that's what I get really jazzed about. But the broad scale of it, we understand it. As scientists, we understand it. Like, we've figured these things out.
Extraordinary group of animals that have ever appeared on this planet.
It's Giroux.
The dinosaurs.
Thank you for the follow. Welcome to Paleontologizing. Anyway, that's part of what I'm trying to do here on Twitch is just, trying to get people excited about this so that they're eager to learn, and hopefully you'll learn something watching this, Yeah.
Children, we make copies of ourselves. We do this by duplicating our DNA and passing that DNA on to future generations.
Yep.
DNA is a chain-like chemical stored inside each one of your cells, which tells them how to grow
the nucleus.
and function.
Yeah.
Your DNA contains coded information on how to build you. The information in your DNA is different than that of, say, a daffodil's DNA, which is why you look and function differently than a daffodil. The information in your DNA is slightly different than that of Elvis Presley, which is one of many reasons you don't look or act quite like he did. Single-celled amoebas and other simple creatures reproduce by copying their DNA inside their guts, moving both copies to either side of their body, splitting in two right down the middle, and then growing back to full size.
Mitosis.
If all goes well, the two new amoebas will be exact copies of each other, but in nature, things aren't always perfect.
Yep. There's going to be a few mistakes along the way.
When DNA is being copied, errors can occur which modify the DNA code. This is what we call a DNA mutation.
Appreciate you.
These mutations can produce variation in the body shape and function of the creature who inherits the modified DNA. In this case, our new little friend has an arm that stretches extra long. If he survives long enough to grow and reproduce, that extra stretchy arm, which is now coded for in his DNA, will be passed on to his children.
So this is a really, really simple idea here, and this is about natural selection and the heritability of traits. And here we go. Let's expand that out a bit here.
A massive amount of observable evidence from many different fields such as genetics, chemistry, paleontology, and mathematics overwhelmingly suggest that just like all dogs share a common ancestor, all living things, me, you, pufferfish, banana trees, if you go back far enough, also share a common ancestor.
Yeah, and this is such a powerful idea. And most people in the US they're completely unfamiliar with this. When we say that different living things are related to one another, that means that they share a recent common ancestor. So think about, what is this? Like, this is some kind of lizard here. I was going to say collared lizard. And this cobra, lizards and snakes both share a common ancestor there. And hence, they've got a lot of traits in common. They've got scaly skin. Many of them have forked tongues. They've got a tail. We've got fossils of snakes that actually have little limbs, little arms and legs for some of the earliest fossil snakes from back when they were still, evolving from that common ancestor. Because snakes actually evolved from a kind of lizard. I guess you could say this clade right here is squamata. These are lizards and snakes. Does that make sense? Yeah. The reason why different creatures look similar to one another and have, the same traits is because they're related. Except when it's trying to fool you. Because sometimes creatures will evolve to look similar even though they come from different ancestors. Remember the Thylacosmilus, the Spracodont, the marsupial saber-toothed cat? Not a cat at all. But sometimes creatures evolve to look similar to one another, even though they don't come from the same ancestor. So anyway, there's a lot of nuance and intrigue here too. This is the basic idea. Common ancestry is super, super important.
We are literally related.
Yep.
We don't know what the first life form was or exactly how it came to be, but the simple process of reproduction with variation over billions of years looks to be responsible for all the diversity of life we see today.
Yep.
Now, you might be saying, wait a minute, hold on here. Isn't evolution random?
Kind of.
To do something
Sort of.
functional like turn a wolf into an adorable mini poodle, random evolution had to be carefully guided by an intelligent dog breeder. Researchers claim that all mammals evolved from an ancient shrew-like creature.
Yep.
But the difference between a shrew and an elephant is far greater than that of a wolf and a poodle.
And it took a lot longer.
Process. Who was the breeder?
Well, natural selection.
In the mid-1800s, two men, Charles Darwin and Alfred Russel Wallace, independently discovered that a breeder is not necessarily needed. There is another force capable...
And this video is great, but I wish they would have shown both of these guys, instead of bearded old men, showed them when they actually came up with the idea. Darwin was in his 30s at the time. I think Wallace was in his late 20s when he came up with natural selection, independently of Darwin. I don't know. Making them bearded old men like this, like, yeah, sure, that was after they had become famous for their ideas, but they had those ideas much earlier on in life. Yeah. And, Amish Andy, thank you for the 28 months of support. I really appreciate that. Yeah. Thanks for keeping me online for the past 28 months, Amish Andy. Thank you, thank you.
Of guiding random evolution to produce order and complex function. They called it natural selection, which happens to be the entire topic of our next video. But before you move on, let's recap what we've learned so far. Biological evolution is any change in the heritable traits within a population across generations. All healthy living things can make copies of themselves, but they do so imperfectly. Small variations can add up over generations to create dramatic differences in the body form and function of living creatures.
Yes, indeed.
Evidence overwhelmingly suggests that all life on Earth is related. So remember, next time you invite family and friends over for a holiday feast, you're actually just inviting family. That includes the turkey and the pumpkin in the pumpkin pie.
It's true.
I'm John Perry, and that's evolution stated clearly.
Good stuff. This is such a wonderful channel, and if you're not familiar with these videos, see about fixing that. He does great work, and I really want to interview him on here at some point. It's going to be tricky to fit all this stuff in before I leave for the field, but yeah. Good stuff. But of course, our topic for today is not actually true bugs. It's this animal here. On a different part of the animal family tree, on the great tree of life, the bilby here. The Australian bilby. There used to be two species, the lesser bilby, now extinct, and now the greater bilby is the only one we still have around. These are really, really cool animals. They're kind of marsupial, and oh shoot. Let's take a look at this.
Under the cover of darkness in remote outback Queensland, one of Australia's most critically endangered marsupials, the bilby, is taking a small leap back from the brink.
Oh.
34 bilbies are travelling 2,200 kilometres by air from Currawinga National Park, where they've been breeding for 21 years, to a new home in the Great Sandy Desert in the Northern Territory.
Bilby numbers are booming here, and we're thankfully in a position now where we can translocate bilbies to other facilities and get one step closer to our dream, which is to have 10,000 bilbies held securely to give us genetic insurance for the next 100 years.
Nice.
The massive mission is a...
Oh, look at that! Oh, man! That would have been a great thing to print for today's background. Didn't even think about a bilby crossing sign. Instead, I got this. This man is your friend. He fights for freedom. Australian. As fun as that is, I feel like that would have been even better. You know what? Next year. Need a GIF of 10,000 bilbies. Paleo Ken, that'd be pretty cool.
Joint project involving the Australian Wildlife Conservancy, the Save the Bilby Fund, the Queensland Department of Environment and Science, Queensland Parks and Wildlife, and the Northern Territory Government. It's hoped this enormous undertaking will help save these endangered marsupials that have been in Australia for millions of years from extinction.
Bilbies live in some of the harshest country in Australia now, which they've been able to adapt to survive in, and it's just so important that we don't lose one more species to extinction in this country.
So Australia actually has the worst extinction record of anywhere in the world. Last year alone, 12 new species got listed as extinct, which is an increase of 39% since the year 2000, which is horrific when you think about it. And if we don't do anything of it, then it's just going to get worse, and catastrophic extinction is inevitable.
Passive traps are gently set with a seed mix to lure the nocturnal marsupials in.
We've found here at Currawenia anyway, they'll trap quite readily. You know, I've got my fingers and toes crossed while I'm saying that, because ultimately it's up to the animals. But no, they trap pretty readily. They're motivated by food.
The field scientists take the trapped bilbies and place them in a familiar environment, a pouch, for transporting to a pop-up vet clinic set on the red soil amongst the mulga. The hum of a generator breaks the night silence as vets carefully check each bilby for the long flight.
So each bilby will come in full of life and vigour, and to do our veterinary examination we need to give some sedation. So we use a mask anaesthetic. So the bilby's restrained in the bag and we put the mask,
gas mask,
onto its face, and that takes about 30 seconds or so. And we've got a little bilby recovering here. So up she goes. So it takes 30 seconds to a minute for the bilbies to go to sleep, and then they get their full vet check from top to tail. We take a little bit of blood, put a microchip in, and the whole thing's finished in about 5 or 10 minutes. So this little fella's ready to go back in his bag.
Stacked on top of each other, or preferably just one level?
Yeah, pretty special, hey? Yeah, no, it's a pretty big deal, but really good to see, and they're going to a great home and really good people. So that's all that matters. You know, they'll be well managed.
Salute to these folks.
That's what it's all about. More bilbies.
Important work here.
See you later, Currawenia bilbies. Go forth and multiply.
It's beautiful. Oh, I love that. Here's a link to that video right here. So again, if you just tuned in, those are bilbies. And that's what we're talking about today. And we're talking about marsupials more broadly. But marsupials didn't just used to be common in Australia. They used to be common in South America as well, and presumably Antarctica too, although I don't know if we found fossils of them there yet. Let's continue with this video from PBS Eons that we veered away from a little bit ago.
Paleontologists have to use complex statistics.
Oh, and Stephen Brusati and Greg Wilson. Shoot, I just saw Greg Wilson not too long ago. Yeah, I used to do fieldwork with him in the Hell Creek.
Programs that analyze things like skulls, teeth, and other bones. Now, by the late Cretaceous period, some of these early Menatherians had arrived from Asia in North America, where they diversified into lots of new species, most of which were small and arboreal. And based on molecular dating methods, the earliest true marsupials seem to have branched off from the other Metatherians at some point around this time, between about 85 million and 66 million years ago. But then something happened. The Cretaceous Paleogene extinction event, also known as the KPG extinction, which wiped out all of the non-avian dinosaurs. And sad to say, all of the Metatherians took a big hit too. About 90% of them went extinct.
And yeah, that's the thing, is that people, when they're, if you know anything about the end Cretaceous extinction event, you know, that asteroid impact and the ensuing ecological devastation, you're probably used to thinking that, you know, well, the dinosaurs went extinct, except for all of the birds and all of the mammals. The birds and the mammals survived, but that's not really a complete picture of this. Here's a nice figure from an upcoming paper about this. These are extinction rates for these different groups of animals at the KPG boundary. So about 20% of crocodilians and champsosaurs went extinct, about 22% of turtle species, 22% of salamanders and their relatives, 40% of freshwater fishes, 92% of the lizards and snakes died out, 100% of the non-bird dinosaurs died out, 94% of the bird species died out then too, and 90% of the mammals, which includes almost all of the Metatherians. Metatherians took a really, really hard hit there. It was rough for everybody, but particularly rough for the birds and the mammals and the lizards and snakes. And the non-bird dinosaurs who got completely wiped out. It was just a KO there. KO, killed opponent.
Extinction, which wiped out all of the non-avian dinosaurs. And sad to say, all of the Metatherians took a big hit too. About 90% of them went extinct. This was probably because many of them were too specialized. They had plant or meat-based diets, while their placental cousins were more flexible omnivores or insect eaters. After the extinction,
and Steger says, where's their microbial life wiped out in that extinction? I'm sure, yeah. I'm sure a bunch of species of microbe also died out. But that's really difficult to test because for all of these critters that we have here, we've got, you know, fossil evidence of them. They left bones for us to find. Microbes don't have bones. There are ways to study them in the fossil record, but I don't think that's actually been done for this extinction event. I don't know if we have an understanding of how microbial life died out, but we do know that in the oceans a bunch of species of plankton went extinct. So this is just a global catastrophe. And it happened, this is the fastest mass extinction in Earth history as well. It happened incredibly quickly, like maybe over just a couple years or something. But yeah, there you go, Ken. That's a great way to think about it. Yeah, all the parasites specifically adapted to non-avian dinosaurs. Yeah. Every kind of fungus and bacterium that was a specialist in like exploiting dinosaurs, that would have died out along with the dinosaurs. All of their gut flora. So like, you know, as human beings, you know that we've got a bunch of bacteria living in our guts, right? Most animals do. If you've got guts, you've got bacteria living in there helping you to do digestion and stuff like that. As human beings, if you were to take every cell in our bodies and count them up, our own human cells would be outnumbered by the number of cells of bacteria and stuff in our guts. Most of the cells in our body are not our own. They don't carry our DNA. They are, you know, bacteria that live within us. Those bacteria that lived inside of the non-avian dinosaurs, they would have gone extinct along with the dinosaurs, it seems. If they don't have a host, if they don't have an environment, then they're gone. So yeah, so microbes also would have suffered a great deal as well. Yeah. And Cosmic Seegan says, so there were crocodilians around separate from dinosaurs? Absolutely, Cosmic Seegan, yeah. There were... so the true crocodilians, I think, evolve in, like, the mid-Jurassic or something? Like Goniopholis. And Lydiasuchus. Yeah, they look a lot like modern crocodilians because they're, you know, they're very, very similar. And on occasion, they would have been eaten by dinosaurs. There's a Gorgosaurus. Looks pretty happy about having caught that Lydiasuchus there. Oh, that poor crocodilomorph. But then sometimes the tables were turned. Yeah, like here, there's Deinosuchus and I think Gorgosaurus again. Deinosuchus is a really, really big alligator-like crocodilian. It might even be an alligatorid, a member of the alligator family. These guys were up to like 30, 40 feet long, maybe. You know, like 12, 13 meters. Huge animals. Huge animals. These guys seem to have gone extinct before the end of the Cretaceous, though. So for whatever reason, they seem to have died out before the time of, like, T-Rex. So them being shown with Corythosaurus here, or is it Hypacrosaurus? Probably Hypacrosaurus. That works. As well as Gorgosaurus here. That's before the end of the Cretaceous. Before the very end. But yeah, you can go see a full-size Deinosuchus skeletal cast at the Natural History Museum of Utah in Salt Lake. Yeah. And Simaisuchus. Yeah, there's a bunch of other weird, cool crocodilians. Armadillosuchus and like these Notosuchians and stuff. I don't want to get on too much of a croc tangent here. Let's get back to our marsupials. Yeah.
Extinction, they soon became minor players in most ecosystems. But there was one place where they maintained their dominance. Some Metatherians had arrived in South America around the end of the Cretaceous, and there they quickly became the most diverse group of mammals, claiming the niches that placentals filled on other continents.
Yep.
For example, one fossil Metatherian from the early Eocene of Brazil glided from tree to tree like a modern-day flying squirrel or sugar glider. Another from the Middle Eocene of Argentina had squarish molars like a primate, and they likely lived like one, eating fruit in the trees. And then there was Pucadelphus.
I don't know a lot about these
from
guys.
the site in Bolivia, which had one weird behavior unlike that of any modern South American Metatherian. It appears to have lived in groups, or at least tolerated frequent social interaction.
Why do we say
Which is
that?
what I try to do. This is based on the discovery of 35 individuals in the same area, including both males and females, adults and juveniles. Their
Living
bones were found
communally?
together, but the skeletons weren't broken apart, so it's not like floodwaters had just washed them into the same area. The
No.
discovery has been interpreted by paleontologists as some of the earliest evidence of social behavior among mammals. But it was another group of non-marsupial Metatherians that would become South America's top mammalian carnivores for millions of years. This relative was called Maulestes, and it's probably the earliest member of a group of Metatherians called the Sparacidonts. It was only the size of a common rat, but it had teeth adapted for slicing meat, and from those beginnings, the Sparacidonts would only get larger and more ferocious.
Does anybody remember talking about Spracidonts a little while ago? We were talking about... Oh, you'll see. You'll see.
This group of predators evolved into lots of forms and thrived throughout most of the Cenozoic era. Like 27 million years ago in Bolivia, there was a Sparacidont the size of a black bear, making it one of the largest Metatherian carnivores ever. And around 14 million years later, an ambush predator the size of a wolverine roamed Colombia. By about 7 million years ago, one group of the Sparacidonts wound up with saber teeth, the Metatherian version of the saber-toothed cats of North America.
Pretty
but this
cool.
group would turn out to be the last of the Sparacidonts and the last of the non-marsupial Metatherians. They stuck around until about 3 million years ago before dying
Presbedard,
out,
well, you're in the
probably
right place.
due to a
Welcome,
cooling
welcome.
climate that limited the availability of their prey. Today, the non-marsupial Metatherians have no living relatives. Their story ends here. Now it would be up to the true marsupials to re-establish Metatherians outside of South America. And one of those early true marsupials was Cassia. It lived alongside Pucadelphus at Teopampa, but its closest living relative is the delightfully tiny marsupial known as the Monito del Monte, found in Chile. We don't know that much about Cassia because it's only...
Monito del Monte means the little monkey of the mountain. Which is not a monkey. But apparently they live in the trees, so they might have similar habits to a little monkey. they're marsupials. Yeah, they're actually kind of a possum, I think.
Monito del Monte, found in Chile. We don't know that much.
Monito del Monte. There's a Simpsons clip I could pull up for that too, but you know, we don't have enough time here. I've got like less than an hour and a half until I have to go to a meeting. So we're gonna continue.
Marsupial known as the Monito del Monte, found in Chile. We don't know that much about Cassia because it's only.
And you know what? You only live once. Yeah. Anyway, that would require more context in order to explain. This reminded me of that. Here goes Marmosaurus, yeah. I'm El Monito del Monte. You killed my father, prepare to die. With my little grabby mammal hands.
Only represented by one fossil, a single tooth. But one tooth can tell you a lot about a mammal. For one thing, it tells us that Cassia was a very small insectivore. It also might have been a climber like its modern-day relative and other metatherians. And more importantly, that tooth tells us that Cassia occupies a very interesting place in the marsupial family tree.
Nice.
It's part of the group of marsupials that today live mostly in Australia. And the Monito del Monte is the only member of this group that's not found in Australia. The marsupials got there by way of Antarctica, when it formed a lush green connection between South America and Australia.
Antarctica is so important, and today we don't have very many fossils from it because it's largely covered in ice, which is a good thing. Let's hope that ice doesn't melt, or bye-bye Florida. But Antarctica used to be this really, really important kind of thoroughfare for critters to move from Australia to South America and vice versa. Such a neat continent.
Antarctica, when it formed a lush green connection between South America and Australia. You might remember this part of the story from our episode about when Antarctica was green. But they weren't the only true marsupials to expand beyond South America. Along with the Monito del Monte, there's a second South American marsupial group that's still around. These are the possums and the shrew possum, the only other marsupials found in the Western Hemisphere today. At least one species, the Virginia possum, returned to North America after it connected to South America about 3 million years ago.
Yeah, this is in what we call GABI, the Great American Biotic Interchange. Where you've got finally North America and South America connected. And you had these critters that could move back and forth between these different continents across that land bridge, the Isthmus of Panama. And those opossums moved north. And now we have them here in the United States. The Virginia opossum, Didelphis virginiana, is one of my favorite North American mammals. And they've been introduced into California, and they're thriving here. They're all over the place. They're such cool critters. They're such cool critters. So yeah, North America does have, or the United States does have one native species of marsupial, and it is the Virginia opossum. Yeah. Commodore says, wasn't the Sahara at one point an oasis? At many points, Commodore, at many points. Big parts of it were underwater. There are whale fossils and plesiosaur fossils from the Sahara. For most of its history, that was not a desert. Yeah. Anywho.
Years ago. And they soon proliferated, becoming the first successful marsupial in North America in millions of years. So those two groups.
And when did mammals get into Africa? Pretty early on, Cosmic Seekin. Yeah. We were talking about that when we were talking about Sirenians and Afrotheres on Wednesday when we did our manatee stream. Yeah.
Groups of
and Ken says we have South American camels. Yeah. So camels migrated south into South America during this event. Camels are originally from North America, and then they migrated south, and then that's where llamas and guanacos, alpacas, and vicuñas come from. It's from those camel ancestors. Oh, we gave South America camels. We did, Ken. Yeah. The way you say it makes it sound like it was a lend-lease thing, you know? The South Americans need camels for victory. And are there remains of marsupials in Africa? I don't think there are, Will62. I don't know if there ever were marsupials in Africa. I think by the time the first marsupials evolved, Africa had already become an island continent and was off on its own, doing its own thing. That's where the Afrotheres evolved. That's the ancestor of, we were talking about this on Wednesday. Afrotheria. It's the ancestors of the elephants and the elephant shrews, the otter shrews, the golden moles, the manatees and their relatives, and all of them are Afrotheres. And the hyraxes, too. Each of these animals are all closely related to each other. They all form a clade together called Afrotheria. And like the marsupials, these guys were able to just diversify into all these wildly different body plans because they didn't have competition from placental mammals. You know, it was free real estate for them, you know, like the meme, you know. It was the same with the marsupials in Australia. There were not a lot of placental mammals in Australia, and so marsupials were able to just go nuts. You know, it's free real estate. So yeah. South Australia full of cool, Dinosaur Dave. Very cool. Yeah, you've been learning about a heap of new marsupials I didn't know about. Awesome. Yeah. But yeah. Commodore says, should we get some camels in North America? Should we import camels, breed them, and release them? Would they be able to survive? Yes. Dinosaur Dave can tell you about his homeland, where there are camels, even though there never were any camels in Australia beforehand. Camels were introduced to Australia, and now I think Australia might have the largest population of wild camels in the world. They're all over the place. Dromedary camels. But yeah. There's an idea that here in North America, we could reintroduce some of the creatures that went extinct during the Pleistocene in order to try and have more functional ecosystems again. This idea that, you know, we could replace some of the creatures that went extinct here. Like the mammoths and mastodons, well, we could bring elephants. They might be functionally similar in the ecosystem. You know, the American lion, we can import African lions. And camels that lived here until just a few thousand years ago, we could bring back Bactrian camels and see if they'll thrive out in largely uninhabited spaces in the American West. Personally, I kind of love this idea, but I'm not an ecologist. Who cares what I think, you know? It would be wonderful to have an ecologist on stream at some point and interview her about, you know, what would Pleistocene rewilding actually entail? What would that be like? Yeah. I have to wait for a lot of ranchers to die. Or just nationalize some of these giant landholding companies that are buying up land from all these ranchers. I mean, the free market is already seeing the part of this. Just have these massive monopoly systems. You know? Just, you know, like, yeah. We're the people of the United States, and we're just, you know, take some of that land, put some camels on it. Yeah. But yeah. Mary L says, ranchers will love you. I'm friends with some ranchers. But it's one of those things like, you know, like with coal mining, where a lot of these jobs hold like a certain degree of romance for the average American, but they're not glamorous jobs. They are very difficult jobs that aren't actually good for anybody. You know, whether you're breathing in coal fumes or putting methane into the atmosphere through cow burps, or dying of things like heart disease because of overconsumption of beef. You know, sure, there might be a certain romanticization of these professions, but if people can make a better living doing other things that are better for them and better for everyone, then let's do that, you know? Yeah. But yeah. Isn't most of the Midwest national parks? No, a tiny proportion, Commodore. Almost none. Prairie ecosystems, for instance, are, they're like... I don't know if I can find this figure, but there is a map of different parts of the U.S. Yeah, shoot. It's like 0.001% of prairie. Shoot. I don't know if I'm going to be able to find that figure, but anyway, almost none of the Midwest is national park. A lot of it was tall grass prairie that was tilled over, turned into farmland, and there was just ecological devastation because of that. Yeah. Oh, and very nice. Thank you, Dinosaur Dave. Cool. And you might be seeing some camels today as you cross the Null Arbor some more. Cool, Dinosaur Dave. I hope you do. But yeah. Anyway, we gotta get back to our topic here. Marsupials, let's continue.
Both found at the site of that ancient flood in Bolivia met very different ends. The true marsupials live on, mostly in Australia, but also in pouches, you might say, of the Americas. But the story of the non-marsupial metatherians, like little Pucadelphus, ended in extinction. So why did one group of this same kind of mammal survive while the other is left to the fossil record? Well, as the Cenozoic went on, the non-marsupial relatives
Instead of settling for knowing what dinosaurs looked like, we now need to know how they lived.
Darth Goof, thank you for the 31 months of support. I really appreciate it. Thanks for keeping me online for the past 31 months. Holy cow. Do I appreciate that. Thank you.
Take the changes in their environment.
Good stuff.
As large-bodied predators, they needed prey, and a changing climate meant a changing ecosystem, one that their prey couldn't adapt to either. But the descendants of Cassia and the other true marsupials survived, because as smaller generalists, they were better able to adapt to a changing environment, unlike groups that got larger and more specialized. And their modern descendants continue to thrive in North America and Australia, thanks to their relative isolation and their ability to adapt to fluctuating resources. While we spend a lot of time thinking about our own branch of the mammal family tree, the placental mammals, the reason there are any members left of the other major branch, the metatherians, is because they were able to thrive and diversify in South America. The survival of unassuming little critters like Cassia all the way back in the Paleocene left a mark on the fauna of the planet, a reminder of the time when marsupials ruled South America.
Pretty cool. Gotta love PBS Eons. They do some great work there. Here is a link to that video. Good stuff. Now, let's see. Let's go to this right here. Australian Geographic. Here's why you should be celebrating the Easter Bilby this year instead of the Easter Bunny. Let's take a look at that as we continue our marsupials
Let's talk about why you should be celebrating the Easter Bilby this year instead of the Easter Bunny. Firstly, bilbies are ecosystem engineers and construct spiral-shaped burrows that, in addition to providing shelter, also help maintain a healthy ecosystem. These 3-meter-long diggings act as compost pits filled with decomposing plant material and germinating seeds. With every digging, bilbies help to regenerate native plants and restore the soil in the harsh Australian desert. Secondly, Australia has been their home for millions of years.
Yeah, which is true for a lot of animals.
Bilbies have been galloping around mainland Australia for roughly 15 million years.
It's so cool how similar they move to rabbits. These are animals that are completely unrelated to rabbits. Like, a rabbit is closer to a whale than it is to a bilby. And yet, bilbies and rabbits, they've got this similar mode of locomotion. They both got long ears. They both dig burrows in the ground. Like, convergent evolution really is impressive when it comes to stuff like this.
Galloping around mainland Australia
Look at that.
for roughly 15 million years.
If it didn't have a long tail, you might go, oh, that's a weird looking
creatures
rabbit.
These days, the ancestors they broke away from 20 million years ago were anything but. But they're not as common as they used to be. 100 years ago, bilbies could be found across 70% of mainland Australia. But shortly after the arrival of European settlers, along with the introduction of the rabbit, the bilbies' range rapidly shrunk to covering just 20% of the country. Now, it's estimated that there are less than 10,000 bilbies scattered across Australia. And finally, bilbies are making a comeback. Funds have been raised through chocolate Easter bilby sales over the last 25 years, and this has helped brighten the future of the real-life bilby.
Very nice. Here's a link to this video as well. Now, in speaking of marsupials, I don't think we've watched this one yet, right? SciShow always does good work as well. Yeah, why celebrate bilbies? Look at them. Just look at them. Aren't they beautiful, Goganek? They're so cute.
Ah, yes, marsupials, the endearingly oddball pouched mammals you find in Australia. Well, that's not entirely fair. There are a solid handful of marsupials in South America and just one genus in North America, the opossum. So how did this lone marsupial wind up so far from all its relatives? Well, as it turns out, it was North America that was once the bustling hotspot for marsupials, long before Australia became the place to be for mammals with a pouch. The fossil record tells us that marsupials didn't get their start in Australia. The oldest ones we know of were found elsewhere. The oldest known ancestor of marsupials is about 125 million years old and was discovered in northeastern China in 2003.
I was going to say, with a name like Sinodelphis, that's got to be from China. And indeed it is. That name basically means, like, Chinese opossum. Sinodelphis. Yeah. Didelphis is the genus name for the Virginia opossum. But yeah. Cephaleme says, do bilbies go on adventures with wizards and dwarves to find dragons? I don't know. Cephalime. I'm not sure.
110 million-year-old fossilized marsupials have also been found in Canada, along with Montana and southwestern Utah in the United States.
Yep, and when I was saying that, like, the reason that we think the first marsupials evolved in North America, it might be just because we've got really good fossil deposits here. Yeah. Montana, Utah, Canada, all areas that have been really, really well explored for Cretaceous fossils. Not necessarily true for other parts of the world. And this is a time when mammals were starting to, like, diversify right before the KPG boundary extinction, where mammals really took off. It's like the the first seeds of the mammal's global success were starting to, they were starting to germinate in the late Cretaceous. And the late Cretaceous of North America is the most well-studied, the most comprehensively collected, late Cretaceous strata anywhere in the world, or here in North America. And so it could be that coincidentally, all of these mammal groups really did just get their start in North America at the time. Or it could just be that that happens to be where we're looking the most intensively. And so that's why we end up finding them. When it could be that some of these groups actually originated in other places. There's a really interesting book about the evolution of mammals and about the history of the study of the evolution of mammals. It's called Beasts of Eden. And I'd recommend it. By David Rains Wallace. I love Wallace's writing style. Beautiful writing style. It can be a little bit dense sometimes, but it feels very literary. Good stuff. But yeah, Beasts of Eden. I ordered this book for Fisher. He's a mammal guy, and I thought he'd appreciate it. But yeah, Beasts of Eden. Walking whales, dawn horses, and the other enigmas of mammal evolution. Good stuff. Excellent book. But one of the continuing themes in this book, things that just pop up again and again, is this idea that, like, oh, well, a certain mammal group, we thought it originated in this area, and then we found earlier fossils of it from Asia, or from Africa, or from Australia. And it turns out a lot of this is sample bias. It's like, well, we just, we're looking under the street lamp because that's where the light is best. So yeah, anyway, good book. Yeah, I've not read that one yet, Neverwinter, so I can't recommend it yet, but I think Fisher said he was starting to read it. Rise and Reign of the Mammals. Yeah. And Golganek, I doubt it. Wallace is a pretty common last name. I don't think there's any relation to David Foster Wallace either. But, I don't know. Let's continue.
And in 2009, researchers uncovered a fossilized skull in limestone from the Bighorn Basin in Wyoming.
Yeah.
An awful lot like a marsupial we all know and love today. It turned out to be the fossil of an ancient marsupial known as a paradectid. These are close relatives of all modern-day opossums. By the way, even though we like to drop the O here in North America, there is a scientific difference between possums and opossums. One is found in Australia, the other in North and South America. The discovery of this skull led researchers to determine that paradectids arose in North America around the time the dinosaurs went extinct, about 65 million years ago. Ancient marsupials, including paradectids, are thought to have moved freely between North and South America. Around this time, however, North and South America separated, and the fate of the marsupials played out differently on each continent. North America's original marsupials actually went extinct. But during the period that South America was isolated from other continents, its marsupials continued to diversify. About 3 million years ago, North and South America decided to get the band back together via the Isthmus of Panama.
The Great American Biotic Interchange,
different animals suddenly had a whole new continent to explore. That included North America's two new, and to this day only, marsupials. One is the Virginia opossum, the only marsupial that is found north of Mexico today, and the other is the southern opossum, found in Mexico and parts of South America. So North America's
Will 16, you should have put an apostrophe there. Opossums came from Ireland. Patrick Opossum.
These are just some of the questions that people ask about dinosaurs.
Alan M21, thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
Marsupials ruled, died out, and rose again, at least in the form of the Virginia opossum, so well known to so many trash bins. And what about Australia? Researchers believe that marsupials made their way.
Yeah, I've never seen an opossum eat out of a trash can. I've definitely seen them eat dog food, like on the back porch of a home where they just like leave food out for the pets, and then like here come 6 different opossums over the course of an evening to just eat all of the dog food. But I've never seen one eat out of a trash can before. Huh. But yeah. Anyway.
Australia, when South America, Australia, and Antarctica were all connected as one landmass. But North America, along with Asia, is actually where they got their start. Researchers are still debating why the early...
Oh, and Commodore says, what's the fine line between a breed and species? I suppose reproductive compatibility. Yeah. So, yeah, Commodore, that's a big problem. Or not a big problem, but like a big matter of continued controversy and discussion is like, where do you draw the line between different species? Or between subspecies and true species? The thing is, we as human beings like to put nature into these neat little tidy boxes because it helps us think about things. It helps us understand the world. But we have to realize at some point that those boxes are also, to a certain degree, artificial. We're doing it for our own convenience. And species are kind of the same way. Like, species are not immutable. They change over time. And they diverge from one another. And at what point when a population splits into two separate populations, and they're evolving in different directions, at what point do they actually become different species, if they can still interbreed? There is no correct answer for that, you know? It's a gray area. It is subjective, inherently. And a lot of people are really uncomfortable with that idea because they like to, they like to have a correct answer, but sometimes there is no correct answer, Sometimes it's a spectrum. Sometimes it's a gray area. In fact, maybe most of the time in nature, it's a spectrum or a gray area in a lot of these things when you're dealing with really granular stuff, So yeah. Yeah. We need good enough answers. There you go, Commodore. Yeah. Bubba Bink says, Darwin said when interbreeding stops, speciation occurs, but that's... And he didn't quite say that absolutely, Bubba Binks. That's one way that's how speciation occurs, but at what point does the interbreeding stop? If you can have two populations that come back together after they've already speciated and create a hybrid, are they actually different species? There are a lot of gray areas there, for sure. Yeah. And it's sturgeons and paddlefish as your fire. Sturgeons and paddlefish. But yes, indeed, that's a pretty cool example. Yeah. But yeah. And you can make a liger and a mule, but they can't pass on their genes. Yeah, but then you do get hybrids of creatures that are from entirely different families that can have fertile offspring. Sometimes they've been separated for tens of millions of years. I was talking about this with Blint on Wednesday night. It turns out it's actually a lot more complicated than that. Here, let's take a look at the sturgeon paddlefish thing. Sturtlefish. Here, this is going to be a video with the same guy. This is also... Oh, no, different guy, sorry. Also from SciShow, on the same channel.
Another critter that caught our attention this...
Here we go.
There's a reason you don't see hybrid animals like ligers running around very much. Not only are they separated by geography, but the genes of different species don't usually play well together. But recently, researchers in Hungary accidentally crossed two very different fish, the Russian sturgeon and the American paddlefish. Their research was published in the journal Genes, documenting hybrid fish that, according to what we know, were not supposed to be possible. These scientists
not
didn't
even
set
remotely
out to make
possible.
a hybrid, though. They were originally trying to create sturgeon offspring that had only their mother's DNA through a process called gynogenesis. Usually, this process involves fertilizing egg cells with deactivated sperm cells from another species, making it possible for only the mother's genetic material to be passed on. In this experiment, the researchers crossed sturgeon eggs with paddlefish sperm because they thought it wouldn't create hybrid offspring. These fish are fairly distantly related, and until now, nobody had been...
I mean, they're separated by like 170 million years of evolution. Like, these aren't just different species. They're not just different genera. They're not just different families. They're different, like, orders of fishes. Super, super, super different from one another.
able to make a sturgeon paddlefish hybrid,
Yeah.
and they'd tried. So that was finding number one. It turns out it is possible. Then the researchers got to work analyzing the anatomy and genetics of the offspring, and what they looked like depended on what kind of chromosomes they inherited, or really how many. See, at some point in evolution, this group of sturgeons acquired another 2 copies of their chromosomes, giving them 4 copies of each chromosome, where paddlefish only have 2.
And so that's nuts. They also just have, like, wildly different numbers of genes as well. Like, I think the sturgeon genome is, like, twice as big as the paddlefish genome. These are very, very different animals, you know? There's no way that they should be able to produce hybrids, and yet they can. And the offspring are viable, from what I understand.
And in the world of fish hybridization, when parents with mismatched sets of chromosomes reproduce, their offspring can
narwhals and
inherit
belugas,
different
they're much
numbers of
closer.
sets. And
Can,
sure
yeah.
enough, the offspring in this experiment could be split into 2 different groups. Some were triploid, meaning they had 2 copies of the sturgeon mom's chromosomes and 1 copy from paddlefish dad for a total of 3 full sets. Or they were pentaploid, with 4 sets from mom and 1 set from dad. Now that's a little strange because in birds, mammals, and reptiles, having more than 2 sets of chromosomes can lead to serious errors in cell division, and it's usually fatal. It's more common in fish. It may have even been an advantage over their evolution, but only in even sets of chromosomes, 2, 4, 6, 8, and so on. Organisms with 3, 5, or 7 sets of chromosomes usually run into fertility problems. In this experiment, the number of sets of chromosomes in the hybrid offspring depended on what they inherited from their parents. The offspring with 3 copies of their chromosomes looked like a pretty even split between sturgeon and paddlefish, while the offspring that got more sturgeon chromosome copies looked a little bit more sturgeon-y. Now, if these 2 fish weren't supposed to be able to reproduce, how'd they pull it off? Well, while these 2 families of fish split a long time ago, the researchers think that their relatively slow rate of evolution means their genes and anatomy hadn't actually diverged that much. And the fact
Yeah, and that right here, when I first heard this as a paleontologist, I'm like, yeah, right. I'm sure they've evolved a lot since, what, the Middle Jurassic? There's got to be a ton of, you know, genomic differences between those Jurassic sturgeon and sturgeon today, or Jurassic paddlefish and paddlefish today. But there was that paper that I was discussing with Balint on Wednesday night, showing that these animals might just have very, very slow rates of mutation. They just don't have a lot of mutations, and as a result, they don't evolve very quickly at all. They're kind of in almost a state of genetic stasis, which is wild to think about. I would always just kind of discount that kind of thinking, like, oh, I'm sure it doesn't actually happen that way. That's oversimplified, but no, it seems like alligator gar, for instance, or gar in general, the lepidosteids and atracosteids, they don't evolve very quickly at all. And those two Atracosteus and Lepidosteids, these 2 different genera of gar, I'm trying to find a picture with both of them here. I guess we'll just look at alligator gar and longnose gar. No, stop. Versus longnose gar. There we go. There's the 2 heads of these different genera. Longnose gar, alligator gar. Turns out they've been separate for like 80 million years or something. They can still interbreed and have fertile offspring. That's nuts. They've been separate for like 80 million years. But these seem to just evolve really slowly. They don't have like high mutation rates. So you can get this kind of beautiful evolutionary stasis. It's wild.
evolution means their genes and anatomy hadn't actually diverged that much. And the fact the sturgeon had 4 chromosome copies might have set up these two fish for increased chances of making successful babies. That's because past fish hybridization experiments have shown that when the mother has more chromosome copies than the father, the hybrid offspring have better odds of survival. So now the researchers are looking into filling up fish farms by making more of these sturgeon hybrids, just on purpose this time. Another critter that caught our attention this week was the yellow-rumped leaf-eared mouse. And
yeah, high as a kite. Yellow-rumped leaf-eared mouse. I think they actually mean in terms of altitude. They live at very high altitude. Yeah, and Bubba Big says, so not different species? No, they are 1,000% different species. Alligator gar and longnose gar, they are 1,000,000,000,000% different species. And yet they can interbreed. So the whole point of showing you that is to say that being different species doesn't necessarily mean that you can't interbreed. That, like, that biological species concept, as we often call it, doesn't work 100% of the time. Species are more complicated than that, you know? Biology is more complicated than that. But yeah. But anyway. Yeah. I'm hearing gar twice, gar species. Yeah, 2 different species of gar are different species, and yet they can still interbreed. Yeah. Anyway. I will ask MS Cancer Institute grad, do you think this contributes to sharks' cancer resistance immunity? I don't know. I know there are certain groups of mammal that seem to get cancer less often than other mammals. But I don't know if that means that they have lower mutation rates. That might mean... Well, it might. I don't know. Yeah. And Cephalim says, doesn't the definition usually... No, that's the thing, Cephalim. There's no the definition. There are a bunch of different definitions for what constitutes a species. Again, it gets into this idea. I think a lot of folks are really uncomfortable with this idea of ambiguity or complexity or gray areas like this, but biology is full of those, and they're wonderful, you know? Biology is much more complicated than sciences like physics, for instance, because in physics, generally you have set rules, and things adhere to those rules. Because in physics, you're dealing with the nuts and bolts of how the universe works. And most of those things are... You're not going to have as many gradients or as many... You know, things are going to be more cut and dry in physics than they are going to be in biology. It's because we're dealing with extraordinary complex things. We're dealing with living organisms. The most complex... Well... I guess they're not the most complex things. The most complex things are ecosystems, because they have organisms, living organisms, as their constituent parts. So just their constituent parts are extremely complex. But the further you go down to where you get to atoms and subatomic particles and stuff like that, kind of the simpler things get, you know? Just by virtue of there being less complexity. You're getting down to the basic building blocks of things. So it's almost like a different way of thinking about learning about these natural systems. If you're studying how atoms interact, there's going to be less ambiguity, fewer gray areas than if you're studying living organisms, you know? Does that make sense? Yeah. Species concepts. What makes a species a species? Another SciShow video. 3rd in a row here. But it's good. We've watched this before.
Classifying living things is kind of like Pokemon. It appeals to our instinct to collect and identify. And the fact that we have a classification system is super useful for scientists. I mean, it shows how every type of organism we know is connected to all the others. We've mapped out all of life in one giant chart. It's amazing when you think about it. But deciding how to classify a new type of organism often isn't simple, especially when it comes to assigning it a species. In some cases, it's obvious when two things should be separate species. A jellyfish clearly is very different from a jaguar. But the more similar organisms get, the harder it can be to sort them. There's no one rule that will always tell you whether two organisms should be in the same species. So
let's have him repeat that real quick, because it's very important, and it's true.
Sort them. There's no one rule that will always tell you whether two organisms should be in the same species. So
yeah, it's complicated. Living things are complicated. There's no silver bullet here to be able to say, oh yeah, these are definitely the same species, but this is a different species. It doesn't work that way.
Different taxonomists use different rules in different situations. The most widespread definition of a species is called the biological species concept, or BSC. It was popularized by evolutionary biologist Ernst Mayr in 1942, and he continued to refine the idea over the next several decades. According to the BSC, organisms are part of the same species if they can produce offspring that can also breed. If they can't produce fertile offspring, that means they belong to separate species. The BSC hinges on the idea of reproductive isolation, where something separates two species to the point that they're not compatible anymore. That separation could be time, or geography, or behavior, or physiology.
And there you go, Charlie's Dragon. This is
willow
true.
Flycatchers used to be considered part of the same species because they meet up in the wild, they look the same, and it seems like they should be able to breed. But ornithologists eventually realized they're totally different species. They sing different songs to attract different mates, so alder flycatchers never try to mate with willow flycatchers. They're reproductively isolated. A species.
But they never interbreed. There could be conditions that could change that would cause them to interbreed, however. You could dream up a scenario in which there's an isolated population, and, you know, conditions change to the point where they suddenly need to interbreed, and then they start doing that. It's just current conditions don't make that happen. These are probably similar enough to one another where they could interbreed. There's probably not like it's a cultural difference between them. Having different songs that they sing, or slightly different habits that keep them from interbreeding. But you change the conditions around them and they might try and do that again. Like they once did, like their ancestors used to be the same species. Alder flycatcher. There we go. Look up them on the Tree of Life. And yeah, that's coy wolves. Yeah, coyotes and wolves. Yeah. There we go. The alder flycatcher. And the willow flycatcher. Apparently, according to this, they've been separate for a while. 1.94 million years? So that is actually enough time where they might not be able to interbreed anymore. I'm not sure. Yeah. But yeah.
Isolate. A species is therefore basically a gene pool, one that doesn't overlap with the gene pools of other species. That's a good, rigorous scientific definition. It can be tested and observed in the wild. But there are lots of cases where it doesn't work, like with microorganisms. Bacteria, for example, don't reproduce sexually. They can share genetic material with each other, but it's not part of the reproductive process. So reproductive isolation is totally irrelevant, and a scientist looking to classify a new species of bacteria can't rely on the BSC. Instead, they might look at genetics, at the shape of the microorganisms and the way they grow, and at their evolutionary relationships to other organisms. You also can't use the BSC to classify fossils, since you can't exactly observe the mating behavior of a skeleton preserved in rock. Sometimes you get...
Although, you know, sometimes you can. Here. It says happen on very rare occasions. Mating turtles fossilized in the act. I think this is from the Messel Pit in Germany, I'm guessing. But it's very rare. Bordering on non-existence.
In an unsuspecting world, living creatures from the dawn of time.
Holy cow.
What havoc will they wreak? What lives will they destroy? What depths of panic and terror will they create?
Skooliki HS, how are you doing?
Skolikis and their 55 raiders have arrived to wreak some sweet, sweet havoc.
Welcome, welcome, Skooliki and Raiders. How are you doing? It is good to have you here. Thank you, Integral, for the follow. Integral, appreciate that follow. And we do be vibin' dough.
I'm interested in your island.
Thank you for the follow as well.
I'm a paleontologist.
Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. Dinosaurs are what I study, what I dig up.
The dinosaurs rule.
Thank you, Kikmakos, for the follow. Welcome, welcome. It's good to have you here. Yeah. Skooliki, how was your stream? I hope it was really, really good. Welcome to the channel. We are celebrating bilbies today. This wonderful Australian marsupial. We're talking about these right before Easter. So we'll get back into that in a minute, but Skooliki, tell me how your stream went, if you don't mind. Looks like you're doing something called Hearthstone? Excellent, and hello to you too, Skooliki. Welcome, welcome. On this channel, we talk about paleontology, fossil science. We talk about natural history. We talk about the evolution and development of life on Earth. With a heavy emphasis on dinosaurs, because dinosaurs are what I actually study, and what I publish on, and what I dig up. But today, we're focusing on marsupials, like the bilby. Since it seems we've got some cool new people here today, like you, Integral, and we do be vibin' and Kidmakos, would any of you like to see a quick welcome video to kind of introduce you to the channel? Type a 1 into the chat if you'd like to see that, and we'll get that going for you. We'll call forth our good friend, previously recorded Danny. Skooliki's got a bunch of ones there. I think that'll do it. And here he comes right behind me right now. Without further ado, I will leave you in the very capable hands of previously recorded Danny, who's going to tell you a little bit about who I am, what in the world a paleontologist is doing here on Twitch, and all that good stuff. So Skooliki, thank you again. Can we get another shout out for Skooliki? And yeah, let's call forth previously recorded Danny. Previously recorded Danny, go ahead and take it away.
Well, thanks, present day Danny. Well, if you happen to be new around here, then welcome to Paleontologizing. You may well be wondering to yourself, well, if this is Twitch, then where are the video games? I'm gonna level with you here. I don't really do much in the way of video games. I'm a paleontologist. My name is Danny Anduza, and dinosaurs are my area of study. But how in the world does a paleontologist end up on Twitch? Well, you're about to find out.
When I finished high school, I moved to Montana and immediately started work at the Museum of the Rockies, which at the time was an unparalleled powerhouse of paleobiology. That program was built by this guy.
Famed paleontologist Alan Grant.
Well, kind of.
You consulted on that movie.
I did consult on all those
and they
movies.
said that the guy Alan Grant was you.
Yes, yeah, well, fortunately he didn't get eaten.
Meet Jack Horner, the real-life Alan Grant. He's one of the most prominent and controversial paleontologists in the country, a dyslexic MacArthur Foundation genius who never finished college and who says he doesn't care why dinosaurs went extinct. To him, the important part is how they lived.
It was at Museum of the Rockies, under the auspices of Jack Horner, that I learned how to be a dinosaur paleontologist. And a huge part of that I learned by working with Jack's final graduate student, a guy by the name of Denver Fowler, who would later go on to become curator of the Badlands Dinosaur Museum. Working with Denver, I did summer after summer of fieldwork in the remote Badlands of Montana. Together, we dug up more dinosaurs than we knew what to do with, at fossil sites numbering in the hundreds. In 2012, I discovered a new species of ceratopsian dinosaur, hopefully soon to be published. The next year, we excavated the world's smallest and youngest Tyrannosaurus rex. Then, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, we found parts of its armor and plates, and so it should be a new species.
Not bad, right? Well, anyway, much like my fieldwork, my research also focuses on dinosaurs.
For example, here's Triarchunkus, the last of the Alvarezsaurs, just published in July of 2020.
One of my current projects focuses on Spinosaurids. I can't really talk too much about that until it's a little bit closer to publication, so stay tuned for that.
Anyway, let's get back to how I ended up on Twitch. A couple years ago, things in Montana were declining rapidly, so I picked up and moved on to greener pastures. I'm so glad I did.
And with that new perspective, I also realized that I have very little patience with the soul-crushing bureaucracy within academia. So for the time being anyway, I decided to take my career in a slightly different direction.
I got hired for a job in early childhood education. As a teacher, I get to have a positive impact on kids' lives and help them find a passion for science. Then, when COVID-19 showed up, the school had to close. But that didn't stop the teaching or the learning. We just moved online.
All right, friends. So we're going to be looking at a book in a little bit, but I thought we'd start off with a song. At 3, 2, 1. Oh, give me a home
where the hadrosaurs roamed, where triceratops bellowed and grazed, where erosion uncovers bones we seek to discover, for to strike the whole world amazed. Home, home on the range, where the deer and the antelope play, where sails on his wing a discouraging word, and the skies are not cloudy all day. It was a pretty easy jump from teaching online to streaming on Twitch. I had my first broadcast in May, and I've been on here ever since. Now, I believe pretty strongly that any good scientist should also be a public servant. In my opinion, talking to everyday people about her science is one of the most important things that a researcher can do. I now have a golden opportunity to reach out directly to people where they are.
This is what I'm all about, and now, thanks to Twitch, I get to share it with you. And I'm so happy to be able to do so.
It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help by following, or if you could afford it by subscribing, I would be deeply grateful.
So anyway, to my regular viewers, thank you again for sitting through this. To everybody who's new, welcome. I'm genuinely, earnestly glad that you're here. And I hope you stick around. We've got a remarkable little community here, and I'd be delighted if you join us. Anyway, let's go ahead and get back into it. So, present day Danny, back to you.
Well, thank you very much, previously recorded Danny. And of course, thank you even more to Skuliki for that wonderful raid there. I appreciate it very much. Yeah, shoot, a lot has changed since I made that video. We're streaming here on Twitch full time now, which is incredible. It's a dream come true for me to be able to do science outreach full time here. And did a bunch of fieldwork streams last year. Gonna be doing even more this year. Digging up dinosaurs live on Twitch, you could say, because
improved.
That'd be true. Here's
Good. Yeah. Well, hello, everybody, and greetings from wild and beautiful eastern Utah.
Digging here in the Cedar Mountain Formation, the very, very beginning of the Cretaceous period.
Looks like I'll be out here again
we just got here
in
last
mid-July.
night. Started to set up camp. We finished setting up camp this morning, or mostly finished anyway. And we opened up the quarry today. So, welcome everybody.
I'm gonna be in Wyoming at the end of May, and less than 2 months now at this point. Very excited about that too. I'll be out in Wyoming for a whole month, and then might have a few weeks off, and then down south to Utah, digging up dinosaurs there. Gonna be live streaming as often as I can, close to every day, if at all possible. So stay tuned, because that's gonna be really cool. But today, we're talking about this lovely critter, the Australian bilby. I've gotta get to it. Gotta hop to it, as it were. These animals do hop. Yeah. Here we go. Let's take a look at this.
In
Yeah.
And you're watching Newsbreak. Coming up on today's show, ditching the Easter Bunny, a kebab in space, and a very special birthday. But before we get into that, why don't you subscribe? These guys everywhere. But a group of conservationists are actually calling on Aussies to ditch the iconic Easter Bunny. Why? Well, we got Leela to find out.
This time of the year, the Easter Bunny is the biggest celebrity around. But not in this story. Gladys, I told you we're doing Easter bilbies this year, not Easter bunnies.
You see, here in Australia, the non-chocolate type of rabbits are an introduced species that cause big issues for our native landscape and animals.
They're invasive.
Instead, conservationists reckon at Easter time, we should be focusing on our very own big-eared cutie, the bilby.
They're super, super cute. They are the most incredible native marsupial.
The problem is, because of introduced predators and habitat loss, there's now only one species of bilby left, the greater bilby. That's why the Save the Bilby movement, which is all about protecting these little fuzzballs with things like breeding programs, have been teaming up with chocolate manufacturers.
So how do chocolate bilbies translate to helping the real bilbies?
It's reminding people that we've got these national marsupials, that they need our support as well. So by buying one of these chocolates, you're actually donating 20 cents to Save the Bilby Fund, which goes a long way in enabling us to continue our vital work.
If eating this chocolate is going to help, it's a tough job, but I might just have to do it this Easter, you know?
Good on you.
Conservation through consumption.
If you're planning on flying anywhere this weekend, get ready for some big...
Anyway, yeah, I hadn't seen that clip before. That was pretty okay. But this incredible animal is a bilby. There. Another quick video.
Hello, my name's Lauren, and this is the lovely Waddle, one of our female bilbies here at Currumbin Wildlife Sanctuary. And we want to let you know a little bit about the Easter bilby, seeing as Easter's coming up. So there's a movement here in Australia to support Easter bilbies, not the Easter bunny. The rabbit is an introduced animal here in Australia and is doing some devastating damage to our environment and our animals as well. The bilby, unfortunately, is endangered here in Queensland. Their numbers could be as low as 400 left in this state. So they are definitely one to support, not the naughty little rabbits out there. So there's a few ways that you can do it. One of them is by buying the Easter bilby chocolates. These are made by Pink Lady with 30 cents going towards Save the Bilby Fund for every one purchased. You can buy them at Target, Myer and David Jones. And another thing that we're promoting for Easter is adopting one of these lovely bilbies here at Currumbin Wildlife Sanctuary. You can do that through our website, and all the money will go towards the wonderful conservation projects that we have here.
There you go.
So from me, Waddle, and everyone here at Currumbin, we'd like to wish you all a happy Easter, and we hope to see you in here checking out our bilbies this holidays.
very cool. Very cool indeed. Rose Sand, I'm so glad that you're here. Because everybody, Rose Sand sent me some chocolate Easter Bilbies. And I will now be opening those so that you can see them. This was not cheap to do either. This was sent all the way from Australia via Australia Post. Pretty special. So thank you, Roseanne, for your generosity and thoughtfulness here. Let's get this opened and take a look at these. Here we go. There we are. And holy cow, this is packed to the gills. I appreciate it so much. Ah! Got a lovely chocolate Bilby right there. Oh, they definitely survived, Roseanne. From Hayes Chocolates. Look at that, that is beautiful. I'm gonna save this little tin, that is lovely. And that's not all. We've got another one right here. Holy moly. And a note. Let me show everybody right here. From Rose Sand. Hello, Paleontologizing in chat. Thank you, Danny, for the many hours of entertainment and education. Thank you, Roseanne. You're a welcome guest to my mornings. This is morning time for you down in Australia, isn't it? Here you have chocolate from 3 places. Hayes and Daryl Leah are larger, and Hayes was one of the first to do bilbies. Wildlife conservation is a... Oh, wildlife conservation is a... Oh, wildlife conservation is a husband and wife team in New South Wales. What? I guess that's the name of an organization. All 3 proceeds go to conservation. Keep up the great work, Roseanne. Roseanne, thank you so much. Thank you for making this possible. Thank you for making our Easter Bilby stream that much more special. We don't just have to talk about it, we've got the real thing here. This really is lovely. Look at that right there. Beautiful Easter Bilby. It looks a lot like the real thing, honestly. Lovely. And we've got this Bilby Chocolates 6-pack. And I love that there's these lovely illustrations of Bilbies all around the packaging there.
Stegosaurus, 25 feet long, weighing 4
and thank
tons.
you, Skooliki, for the 6 months of support.
He won a lot of arguments in his time, but very few beauty contests.
I appreciate that, Skooliki. Thank you for your support
Paleo
past 6
Apato
months.
1, Paleo Apato 2,
That's excellent.
Paleo Apato 3, Paleo Apato 4.
And look at this! Our organic Bilby chocolate is not just delicious, but also helps Bilby conservation efforts across Australia. Bilby is one of Australia's most amazing marsupials. Once occurring across large parts of the country, they are now only found in a few small isolated pockets where conservation efforts are necessary to protect this beautiful and iconic animal. We give 10% of the net profits to organizations which are implementing on-ground projects critical to the Bilby's survival. Very nice. You can visit easterbilby.org.au if you'd like to learn more. And look at these. This really doesn't quite do it justice. I might have to take it out of the wrapper here so you can see, but this is beautiful. Look at that. And this has been shipped halfway across the world, and it still looks this good. Imagine what it looks like if you're there in Australia and you just pick one up off the shelf. That is a lovely, lovely rendering of a bilby there. I am super impressed. I'm gonna... You know what? Let's try one. That's really good. Very smooth. It's got kind of a dark chocolate taste, but it's not too bitter. I like that a lot. Australian chocolate, who knew? Good stuff. And I saw that, Roshan. It's right here. Show that off too. Dark chocolate sweetened with local honey. It's got that kind of richness that you get from a good dark chocolate, but it's not too bitter. I think the honey kind of cuts down on the bitterness a bit. This is excellent. Thank you. Holy cow. A milk chocolate one here too. And these, we'll open these in a minute. I'll be, I think, sharing these with Lordy and Ios this weekend as well. Yeah. And hey, now you're an L-star. Likewise, Murph. The real All-Star here is Roseanne for sending these. And there's a lovely tote bag there with some bilbies on it. This is brilliant. Look at that. Yeah. Oh, that makes me smile. Shoot, I think the whole Easter bilby thing really appeals to me as a dinosaur paleontologist because I recognize that depictions of animals in culture can endear them to people. People get excited about critters that they see in popular culture, or on TV, or on a store's shelves. And that can lead to very good things. You know, when Jurassic Park came out in 1993, there was this massive resurgence in the public interest. Well, in the public, you know, interest in dinosaurs was huge in the 90s. And that had a, direct material benefit for us as dinosaur paleontologists. Because suddenly, dinosaur exhibits in museums were all the rage. Even more so than they had been before. Suddenly, there were more jobs for paleontologists almost overnight. And that led to a big resurgence in scientific interest in dinosaurs as well. If you could have more dinosaur paleontologists digging up more dinosaurs, describing them, studying them, and then talking about them to the public, kind of creates this wonderful feedback loop where the more we learn about dinosaurs, the more we want to know about dinosaurs, the more that dinosaur research gets funded, which leads to more discoveries, which leads to more public interest in dinosaurs. And I really hope that the same thing is happening here with the bilby. I'm not from Australia. I don't know how well known these animals are within Australian borders. How many people in Australia actually knew about these animals before the whole Easter bilby thing? But I'd be willing to guess that more people know about these animals, learn about them at a younger age, because of the Easter bilby campaign. I think that's really, really cool. Of course I would say this because I'm here on Twitch and you know, general public interest is what pays my bills here. But this is important stuff. It's important to get the general public interested in things, to introduce them to animals like the bilby, and say, hey, there's this wonderful, beautiful, unique animal. You should care about this animal. You're gonna love this animal. Let me show it to you. To do that through stuff like the whole Easter Bilby campaign, I think not only does it work, but I think it warms my heart. I just love to see it, you know? Yeah. The Behind the News program is usually shown in schools as part of the activities. Very cool, Rosand. That's very, very cool. Yeah. Good stuff. Good stuff. Yeah. And Golganek wants to know, are bilbies technically considered a macropod? They're not. No, they're related to bandicoots. And, it's another whimsically named animal as well. Whimsically named. I hope I'm not sounding condescending. So many of these Australian words are so cool. They might come from the original inhabitants of Australia as well. From like Aboriginal languages, but I'm not sure. Yeah, here, let's search Wikipedia for bilby, and let's get the lowdown on their phylogeny. So genus Macrotus is the bilby. I've actually got a bunch of genus Macrotus all over the wall here. A skeleton and a skull right here. Various illustrations on the wall today. But yeah, they are members of the order Paramelomorphia, which includes the bandicoots and the bilbies. There you go. Yeah. They've got the characteristic bandicoot shape, a plump, arch-backed body with a long, delicately tapering snout, very large upright ears, relatively long, thin legs, and a thin tail. So that's an example right there. It's a short-nosed bandicoot. And, yeah, so they're not closely related to the wombats or the koalas or the kangaroos. They're from a different group. Let's see if we can find a phylogeny here. Interesting, but we've had different interpretations from different researchers over the years. And bandicoots are not extinct. They're still around, Commodore. Yeah. But yeah. My favorite Aussie animal name is Wabagong. You can't not say it in an Australian accent. There you go. Wabagongs are really, really cool. Those flat sharks with all the like tassel things coming off their faces. Yeah. But yeah, here, let's take a look. Let's find a nice cladogram. Marsupial cladogram. There we go. This is the same one that I have printed out on the wall right now. Where is that? There we go. Image in new tab. Yeah. So, coming out of South America, you had the ones that went into North America, Didelphomorphia, which are the Virginia opossum and its relatives. And you've got these South American opossums here. And then you've got all these Australian marsupials. There's the bilby right there, within Paramelomorphia, genus Macrotus. That's the bilby. So they're pretty far from your macropods, like Macropus, that's the giant red kangaroo. Or greater red kangaroo, whatever their common name is, I forget. But yeah, you've got so many cool and weird and wacky marsupials like this. Marsupial moles and Tasmanian devils, kangaroos and koalas and wombats, and all kinds of different really, really interesting marsupials. We should do another marsupial stream sometime soon. But, yeah. For right now, we're pretty much out of time. I started extra early today because I have a museum meeting that I've got to attend in just a few minutes here. So I'm going to get ready for that. Make sure that my whole OBS setup actually works with Google Teams because I've never tried that before. So I have to sign off now and get that started up. So thank you, everybody, for a wonderful stream today. And I hope you had as much fun as I did. And hope you've got a newfound appreciation for these wonderful animals, bilbies, and for marsupials in general, and for, you know, the history of life on our incredible planet as a whole. I hope you're jazzed to learn about this even more now. Thanks for watching. Don't go away yet. We're going to go right into somebody else doing some science here on Twitch. And here is a non-marsupial. This is a placental saber-toothed cat. Maybe one of these days I'll be able to 3D print the Thylacosmilus, because that would be cool to have. Yeah. Let's see who else is here on Twitch right now doing some science. Thank you to everybody who's appearing in our credits currently. Appreciate you more than you know. Let's see here. Who else is on? This is not my normal streaming time, so pickings are a little bit slim right now. Let's see. You know what? Let's... Can we raid into Bob Ross? Do they allow raids? Nope, this channel is disabled raids. Well, forget that. What's Nicotine doing right now? Oh, a game. Okay, I thought she was doing some programming. Oh, I see a turkey on the Critter Vision cam. We're gonna go raid Critter Vision. That'll be good. Very cool. And we're gonna see some... We might even get lucky and see some marsupials. Maybe an opossum would show up, but they usually come by at night. But if you ever want to see live opossums doing their thing on Twitch, Critter Vision is the place to do it. Thank you, everybody, again, for a good stream today. I hope you had as much fun as I did. And I gotta go get ready. So let's go right into Critter Vision, and I'll see you all again on Monday. You take care of yourselves, and have a good weekend. Bye for now.